I'm not saying it's aliens, but it's not aliens. Hello wonderful person, this is Anton, and today I really wanted to talk about this recent announcement / press release that actually doesn't have a scientific paper attached to it just yet, but the papers are coming out. All of this is based on a story that came out in The Guardian, and it's also based on what seems to be a leak from the actual scientists themselves, or possibly from one of the researchers that just couldn't hold it. The idea here is that we may have detected yet another unusual signal coming from an extremely close exoplanetary system to us. The system we're looking at right here, Proxima Centauri, the system that has the nearest terrestrial planet in the habitable zone. And this signal is very reminiscent of the 1977 signal known as the WOW signal that is even today not particularly understood very well because we haven't really been able to detect it again. In other words, what I wanted to talk about today is a potential detection of maybe a technosignature, but most likely something that actually came from planet Earth, but we just couldn't identify what it is just yet. And the reason this is so exciting is because it's coming from the world's biggest technosignature investigation project known as Breakthrough Listen, the incredible project that was started 5 years ago by some really prominent people. And the idea here was to essentially fund as many possible listening hours on various radio telescopes as possible. But obviously in our search for extraterrestrial intelligence somewhere out there, we've already discovered a lot of potential signals that were later on found to be nothing more but signals from planet Earth. Or even signals from a common microwave, the signal that was known as the periton that I discussed in one of the previous videos. And so what exactly makes this particular detection special, and why are we even talking about it? Unfortunately, until the papers come out, we're not going to know the details just yet, but from what we've already been told, this signal is specifically interesting for, well, three main reasons. Reason number one is its location. It seems to be coming from Proxima Centauri, because when the scientists were looking at a different location slightly away from Proxima Centauri, the signal disappeared. We know that Proxima Centauri's system is extremely interesting. Despite this being a red dwarf, it contains at least one planet in the habitable zone, the planet we refer to as Proxima b, and it does contain another planet known as Proxima c that's much farther away from the star and most likely is some sort of a frozen terrestrial world. Or maybe some sort of a frozen ice giant. Either way, there are at least two planets here, but possibly even three. And at a distance of 4.26 light years away from us, this is as close as it gets. So having a planet in a habitable zone and so close to us is always exciting for us. And so back in 2019, scientists were using this beautiful Australian observatory known as the Parkes Observatory, actually one of the most famous radio telescopes out there, to try to investigate potential emissions coming from the planet simply because they were studying the ridiculously powerful flares coming from the Proxima Centauri star in order for us to really understand how this affects the planets. So by studying the radio signals from the flares, we might be able to get an idea of how powerful these flares are and how likely the planet might actually still have, for example, atmosphere and water. But luckily for us, or I guess surprisingly for us, one of the signals coming from the system was very similar to what we normally detect from planet Earth when it comes to basically just technosignatures, signatures of technology. So for example, compared to, let's say, a fast radio burst, which was also a mysterious signal that we're still kind of trying to solve, where normally you'll see several different frequencies in the signal itself, and various FRBs will have different frequencies. What's unusual about this particular signal from Proxima Centauri is that it seems to be similar to a single tone of a single frequency of exactly 982 MHz, or actually 982.002 MHz. And that's extremely precise and doesn't seem to change or modulate in any way. In other words, the signal doesn't seem to contain any information, but it does seem to be unnaturally flat, unnaturally constant, that is, which currently just does not have any explanation. Now, before we continue though, quick clarification. Normally, and this is what actually happened to a lot of these signals that were detected in the past, in most cases, these signals turn out to be, for example, flying satellites right above the point where we're looking at, and in many cases, these are either radio communication satellites, or in some cases, military satellites that have some sort of a secret technology on board. But in this particular case, the frequency doesn't seem to be associated with anything that we currently have in space, unless of course it is some sort of a maybe secret Chinese satellite for all we know. At the same time, because these satellite dishes are so sensitive, even a tiny radio transmission from somewhere nearby could actually accidentally produce these fake signals. This has happened many times before, and at the moment this is still a possibility. It just at this point nobody knows what exactly could have produced this specific signal. But because the signature of the signal is extremely similar to what we normally produce here on planet Earth, it seems to be, well, unnatural, in the sense that it's produced by some sort of a technology maybe. We just cannot make an assumption yet that it actually came from Proxima Centauri, simply because there's still a chance it was basically maybe captured by something that was passing overhead, or something that was nearby, very close to the satellite dish. Now, the press release does mention that at least 4 signals were detected, but some may have been just radio interference, and this was over a period of several days. So if there was something hanging over this area, for example in outer space, it could have been maybe a geostationary object. But at this point we don't really know, and we cannot really assume this, because when they tried to look at this location very recently, nothing was actually discovered there. So if it was an actual signal coming from, for example, space, from maybe a satellite that was there, it may have shifted locations and is most likely not there anymore. And if by some unusual chance this was a signal coming from Proxima Centauri, which is a big if, in this case someone just turned it off. It's no longer emitting anything anymore. But once again, this is a really big if, and very likely is going to be proven in the next few years to be something most likely artificial, made by humans, and that was just emitting the signals in this particular frequency. Now, just for fun, I actually tried to look up if anything that we know does emit 982 MHz, and except for this particular study that investigates these very unique lasers that are used in communication that do emit frequency by essentially blinking the lasers at frequency of about 982 MHz, there was really nothing else I discovered. And these particular lasers also have a very unique application in essentially fiber communication. I'm not entirely sure if there is some sort of a fiber that might have been causing this, maybe some sort of a cable connection close to the satellite dish, but for all we know, this could have been actually one of the possible explanations. Because if you remember, 5 years ago, the explanation for the so-called periton signals was the microwave oven that was actually located not so far from the Parkes Observatory. So the previous unknown radio signals from this observatory were nothing more but someone just opening microwave oven a little bit too soon. But the reason so many scientists are going to be very eagerly awaiting these scientific papers to come out is really because even when there is a tiny possibility that it is aliens, everyone is going to try to investigate this, simply because a lot of our science really depends on this, depends on discovering extraterrestrial intelligence somewhere out there. But in all of the previous attempts, so far it's been just something very easily explainable, such as, for example, pulsars. And for all we know, maybe this particular discovery will actually lead to a discovery of a new phenomenon we've never known existed around various exoplanets before. But that's not all. There's actually something else that was really interesting about this discovery, coming from the tiny pieces of information that were thrown to us by whoever leaked the information to begin with. So it turns out that the signal itself was also slightly blue shifted, or essentially its frequency was increasing a little bit, suggesting that it was moving toward the planet Earth. Or at least that's just one of the implications. It just means that the signal is moving closer to us because the frequency is going up. Now, this blue shifting is very well understood, so we can actually figure out how fast it's moving, but until the papers come out, we're not going to be able to know anything about it. And also, unless we actually see the signal again, and unless we're able to somehow detect it from exactly the same location as we found it before, we're not going to be able to confirm this as a technosignature or any kind of an interesting alien signature. It's just going to remain as a potential disturbance from something else terrestrial that we just couldn't figure out. Now, like I said before, 982 MHz is not a very well-used frequency. It's not something we normally use on Earth, but it could also be just someone's broken radio, someone's cell phone not functioning properly, or a plethora of other things that do produce radio frequencies in that specific way, especially because we know in the past very similar signals have been detected and already discredited as something that was basically produced by a device on planet Earth. Nevertheless, the signal has officially been given the designation BLC1, which stands for Breakthrough Listen Candidate 1, because this is the first time we've ever found a signal that has sort of passed all of the other filters. It's exciting enough for us to do a lot of follow-up studies and to try to discover what actually produced this after all. Now, probably not aliens, but at this point, I'm sure a lot of scientists are going to put a lot of research into this to find out who truly did it and what actually caused this. But I guess for now, I'm not really going to speculate any more about this, because there's just nothing else I know except for what you can read in the amazing article written by it's the daughter of Frank Drake, Nadia Drake, who wrote a pretty good article about this that I'm leaving in the description below. But the main researcher doing all of this is this wonderful person, Sonia Sheikh, who I'm sure is going to release the paper about all of this sometime soon. And hopefully really soon, because a lot of us are so excited to see what actually was discovered back in April and May of 2019. Because that's when the original signals were detected, and we've just identified them very recently. But until we learn more and until those papers come out, that is unfortunately all I have for you. It's a pretty exciting announcement, it's definitely something really interesting, reminiscent of 1977, and it's something that many scientists will be very eager to learn about and to study in the upcoming months. Hello, wonderful person. Oh, I'm transparent. Be right back. Right, that's better. You know, I have so many green t-shirts that I love wearing, but I can't wear them on camera because of the green screen. Anyway, getting distracted. Today we're talking about tardigrades or water bears once again, because it just so happens that there was a very interesting and somewhat cruel experiment very recently, where the scientists took these little things and shot them out of a bullet, in order to see if they can actually survive extremely high accelerations and obviously collisions as well. But the question is, why? And the answer is for two main reasons. One of those reasons is to try to answer the question of panspermia. So would, for example, different types of creatures such as water bears be able to pass from one planet to another via asteroids that collide with various planets? Because the collision impact might be very stressful and obviously produce a lot of acceleration and a lot of force, it's very important to establish if these creatures can even survive these conditions. But the second question was a little bit more practical. Back in 2019, Israel launched a lander that was supposed to land on the moon and deliver a bunch of scientific missions. Unfortunately, the lander was not able to control its descent and crashed into the moon with a relatively fast velocity, somewhat equivalent to the velocity of a moving bullet. But it just so happens that some of the passengers on that particular lander were our favorite tardigrades, also known as water bears or moss piglets. Anyway, so they were actually on the capsule, and so when the capsule crashed, a lot of scientists were trying to figure out, well, first of all, did they survive the crash? And second of all, is there any chance that they might still be there and still kind of be alive? One thing about tardigrades that we've discovered, and you can actually learn more about this in one of the previous videos, is that they obviously have a lot of resilience. When things don't go well for them, water bears have a tendency to change dramatically, becoming what's known as the ton state, which is a very unusual and very strange state where they basically transform into these seed-like components that sort of become almost completely indestructible. They are able to survive very high temperatures, very low temperatures. They're also able to survive in what seems to be outer space for at least a few days. And they also acquire a very interesting protein that tends to sort of protect their DNA from a lot of various radiation. All of these features are also discussed in that previous video, and because of this they are extremely interesting creatures. But did they survive the moon landing or the moon crash? Or basically, how violent of a crash can these creatures survive in their ton state? Would they be able to survive an asteroid crash and thus be transported to, for example, Mars or Venus billions of years ago? Are we actually going to be able to find any of these tardigrades somewhere else out there in the solar system from some of the previous collisions on our planet? And this is really important because it sort of allows us to put a bit of a constraint on what kind of an extraterrestrial life we can find somewhere out there, at least in our own solar system. If we can find the limits of the survival of life in outer space, and of course in these cataclysmic events such as asteroid crashes, we might be able to then start making different theories about where we can and cannot find life after all. While at the same time, this of course also helps us understand if the panspermia model, which can sometimes imply that life should be found everywhere, every single nebula, every single planetary system, and so by putting these constraints by using various experiments, we can maybe define these ideas a little bit better. So right now, the idea of panspermia is still a hypothesis. It does not actually have any physical proof or any observational proof whatsoever. We obviously have found various types of organic molecules and various types of amino acids in comets, asteroids, and even various nebula out there, but none of this indicates that any of this is life or that this was signs of life. It's just the molecules that life is made out of. And so this is why studies like this one from a few years ago try to estimate and try to calculate what exactly can life survive in terms of cataclysmic events and in terms of being transported from one planet to another. But I guess this particular paper that was just released not so long ago makes it even more sort of interesting and somewhat practical. And here's what they did. They took a bunch of these individual tardigrades. This one here is actually very well known Hypsibius dujardini. That's one of the most well-studied freshwater tardigrades and is often used in various astrobiology studies, and they placed them into, well, let me show you. This is what's known as the two-stage light gas gun, and it works as follows. You place a bullet in one of the sides here, and it essentially has two different stages where the bullet accelerates even more. When the bullet is fired, it can actually reach speeds up to about 8 to 9 kilometers per second. And today, NASA usually uses these to simulate the effects of various high-speed collisions between satellites, or sometimes trying to understand what happens when, for example, an asteroid collides with our planet. And basically, this is what they did. They shot these water bearers at really high speeds. Although luckily for the water bearers, they were in their ton state, so they were not actually aware of what's happening. And by the way, the reason it's called two-stage gun is because the first stage here is just a regular bullet, it uses gunpowder, but the second stage, which is the stage that's coming up right here, normally uses a light gas such as helium to pressurize it to such an extent that it literally fires off the last pellet at ridiculously fast speeds. And this is what you see happening right here. And so inside this tiny red pellet, that was a tiny water bear flying at very high velocities. But in this particular case, they did not use super high velocities. They didn't really go all the way to 8 kilometers per second. These speeds they were testing were between about 550 meters per second and approximately 1 kilometer per second. And once the water bear hit the final sand target, they took all of the sand and then collected it, put it in the water, and then watched them come back to life. With some other lucky tardigrades, approximately 20 of them, used as a control and just frozen and not really fired from any gun. But what about those unlucky experimental targets that were fired from the gun? Well, according to the study, the velocity of 825 meters per second, which is around 2700 feet per second, was the cutoff point for when the water bear was no longer able to survive. Everything over this speed resulted in the production of a lot of various fragments, and nothing was left alive anymore. And the ones that did survive these collisions took much longer to recover as well, which of course suggested that there was quite a lot of various types of damage on the inside. The survival rate up to about 800 meters per second was about just over 50 to 60%. Whereas once the pellet was moving much faster, no tardigrade was alive after this. And these conclusions could actually provide enough information to answer some of these questions I tried to ask previously. So for example, the tardigrades on the moon here experienced a collision that was possibly a little bit higher than 1 kilometer per second. When the lander crashed into the moon, it was moving horizontally at over 900 meters per second, and it was also moving vertically at over 140 meters per second. So the overall pressure of the collision could have been much higher. Although it's not really certain, and we're not really going to know what happened to them until we actually go there and see what happened to the capsule. At the same time, this sort of puts the idea of meteorites transferring tardigrades to, for example, Moon and Mars and so on, sort of out of the question. The collisions here produce so much more pressure that they would most likely shred these creatures apart. And in this case, the scientists went on and tried to calculate some other possible collisions with other planets, like for example Mars or Moon transfers. And so even if these creatures originally lived on Mars or originally lived on the Moon, any asteroid collision in this case would produce way more pressure than these creatures can handle. And so trying to transfer these creatures via asteroids seems to be most likely impossible. Which of course definitely limits this idea of panspermia, at least for these very resilient creatures. Okay, but there's actually one more question that the scientists wanted to answer. Let's just say hypothetically that these creatures do exist on some of the moons of Saturn and Jupiter, specifically in the oceans of Europa and Enceladus. NASA is actually already planning one of the missions to sort of fly by and try to capture some of the particles from these beautiful sprays that have been detected on Enceladus. These geysers may potentially release some of these creatures, if they exist there, into the outer space. but if the mission flies by and tries to capture them, it will still actually produce a lot of pressure simply because of the velocity difference. Will these creatures survive hypothetically if they crash into the spacecraft? Will the spacecraft be able to recover any possible life from these objects? And so here they decided to crunch some numbers for both of these objects, for Europa, which is the moon of Jupiter, and Enceladus, the moon of Saturn. And for both of them they found a possible solution. In case of Europa, even though the speeds might be still too high, by using a certain type of aerogel that can actually soften the blow, and that's already been used in space for various missions, they could hypothetically lower the pressures and allow potential creatures to survive. At the same time, there are certain pathways around Enceladus that can be taken, where the total pressure might even allow the scientists to capture these creatures alive, even without the use of aerogel. So in that sense, these missions are quite promising. And so in that sense, the mission that NASA currently refers to as the Europa Clipper does have a very high chance to potentially discover something alive, assuming of course they put a little bit of aerogel in there. Now this mission is officially starting in 2024, so there are still a few years to sort of plan all of this, but chances to discover something absolutely incredible in the next few years is actually really high right now. But to answer the question of whether these water bears would survive a collision with an asteroid, and thus be able to somehow transport themselves to another object in the solar system, seems to be no, not really. It looks like they're resilient, but not immortal. They do fall apart once the actual velocities reach the speed of about 1 km per second, or actually even closer to about 900 meters per second. And so in that sense, this discovery and this experiment is super interesting. But obviously more experiments will be needed, and possibly even using some other creatures or some other bacteria, for example, such as the one I mentioned in one of the previous videos, to determine if panspermia can happen on bacterial scale. Could a bacteria survive these very high velocities and these pressures created through these collisions? Now that's a question we're going to be talking about in one of the future videos. Hello wonderful person, this is Anton, and today we're going to be discussing a new interesting visitor to the International Space Station. The visitor being the Blob, sort of named after the 1958 horror movie also known as The Blob. And if you've never seen this movie, it essentially features a slimy organism that sort of grows bigger and bigger and starts to consume everything around it, including humans and eventually even bigger objects. Anyway, I'm not going to be spoiling the whole movie, and in this case, it's not really that blob that's headed to the ISS. It's actually this one right here. This is known as a slime mold, and this is, in my opinion, one of the most fascinating, if not the most fascinating, organisms on the planet that's been used in various studies for many decades now. And this video right here you're watching is also in the description below, which is a really cool visual art project from an artist by the name of Heather Barnett, where she essentially uses this mold for various experiments just to see what it does when you put it in a certain situation. Anyway, this is a really fascinating organism, and there's just so much to discuss in regards to it. This is an organism known as Physarum polycephalum, and it normally resembles this. Although sometimes it also resembles something like this, so it does kinda look like a mushroom, and because of this it was generally considered to be a fungi or a mushroom for an extremely long time. And at least visually, it does resemble a mushroom. But not so long ago, the scientists realized that this is actually not a mushroom at all. As a matter of fact, this is an organism that completely defies modern biology. Because even though it sort of resembles a mushroom, in reality this is actually a single cell made up out of multiple nuclei. A single cell that, as you can see right here, is growing without ever dividing. Which makes this an absolutely fascinating organism. And there are so many other things that make this organism extremely fascinating and somewhat weird. Now first of all, generally speaking, what you're looking at right here is just one of the forms of this organism. Physarum can actually live in different forms. So for example, this form right here, this happens when there's just not enough food in the environment and suddenly the mold tries to find food elsewhere. And so it starts to actively search for the food by combining all of these cells into one large cell, and by then trying to explore the environment, as you see right here, searching for the signs of potential food source. But when there's a lot of food in the environment, each of the individual nuclei starts to separate and creates its own tiny cell, its own tiny amoeba, with each of them living their own separate lives until there's no more food left again. And at that point, they once again create this large cell, start to look for food, and if nothing is found, some of the species are even able to create these mushroom-like formations, which generally just sit there waiting for something to pick them up to take them to a new place. And that something could be anything: an animal, a gust of wind, or just something brushing against it. But because it kind of looks like a mushroom, back in the days the scientists believed that this was a fungi. Turns out that it's not a fungi, or a plant, or an animal, but belongs to a category that's never really been classified very well. The category we refer to as protists, which really makes these creatures especially interesting. Mostly because a lot of them have really unusual features that no other species has on the planet. So for example, when it comes to reproduction, instead of having 2 genders like most species on the planet, many slime molds will have up to several hundred. With this species in particular having anywhere from 500 to maybe 900. Which of course allows the species to differentiate extremely quickly and to also survive even in some of the more extreme conditions. And so generally speaking, when we talk about slime molds, we really are referring to this unusual organism that normally lives as a free single cell, but sometimes comes together into a multicellular reproductive structure that the scientists sometimes refer to as the blob. A slimy, slow-moving organism whose only purpose is to find more food. And interestingly, in this state, this organism also acquires some absolutely incredible features. First of all, they acquire an ability to sense the environment, sense chemicals, sense pressure, and even sense light, and possibly some other things we haven't discovered yet. They also acquire an incredible ability to create these very complex structures and to move around using what's known as the chemotaxis, following the chemicals. But more importantly, the scientists over the past few decades discovered that it also seems to have an ability to learn, to remember, and possesses some really complex problem-solving abilities, which is something that I guess a lot of people didn't really expect. Which is where we come to this important point of this video: intelligence. This organism seems to possess intelligence, but not the type of intelligence that animals have. At least not the intelligence where you need to have a brain, neurons, and electrical stimulation and electrical signals in order to be defined as an intelligent species. Because we know for a fact this has no neurons, this also has no electrical activity on the inside, and so there is no complex brain involved when it comes to intelligence for this particular species. Yet with absolute certainty, most scientists today would actually refer to this as an intelligent species, as something possessing intelligence. As a matter of fact, in several different studies, this strange mold has already showed the scientists what it's capable of. It was able to solve mazes that normally have only been solved by mice. It's also been shown to have very similar features and very similar behavior to what we usually expect from a social insect such as a bee, with one example being something like this: when all of the cells inside the slime work together to create some sort of a stalk-like formation, with the bottom cells sacrificing themselves in order for the top cells to be transported somewhere else. But more importantly, time and time again, the scientists have been able to show that this mold is able to solve some really complex mathematical problems when it comes to pathfinding. With one really famous example being this unusual map of Tokyo created by the Japanese scientists. By taking several pieces of oatmeal you can see represented as white dots and placing them in various regions representing the map of Japan, specifically the map of metropolitan Tokyo that's today considered to be the largest city in the world. They observed the mold itself create the shortest pathways to each individual city, and within 26 hours it actually created the shortest possible paths and the most efficient paths to each of the locations, which represented an almost direct copy of the subway map of the metropolitan Tokyo. And so when presented with several food sources, it's able to solve the shortest path problem by creating the optimal routes to every location where the food is present. And very similar experiments have been conducted using other city maps, including the maps of Spain, Portugal, and United Kingdom. But it's not just able to solve these mathematical problems, it's also able to somehow remember. It seems to have memory. To test this, the Japanese scientists essentially changed the environment the mold was growing in every 60 minutes. They would basically make the conditions extremely cold and extremely dry. And so after a while, they stopped doing this. But the mold was anticipating the changes. It actually prepared itself as if the conditions were about to happen. And that is not something we expect from a simple organism that does not have a brain. It's something that you usually expect from something that does possess some sort of an intelligence. And to top this all off, some of the scientists have even created a kind of a robot, with the mold itself being responsible for the locomotion or essentially the movement of the robot itself, with the actual control being somewhat simple and looking kinda like this. And as soon as it learned to control the robot, it essentially moved it to the location that the mode prefers to live in, a dark and a somewhat wet place, something you can learn more about in the paper in the description below. And so what all of this shows is that this unusual creature, this organism, is able to solve a lot of really complex mathematical problems, without generally understanding what math is, of course. But it doesn't just solve them, it also remembers some of the solutions. So this paper right here, for example, once again showed that this organism is able to remember certain types of substances that it doesn't really like. And so when the scientists introduced a substance that the mole didn't really enjoy, it ended up creating a lot of really complex shapes just to escape the environment. And so all of these discoveries are slowly helping the scientists to figure out what exactly intelligence is, or what features an organism must have in order to possess intelligence. Obviously, we always believed that the brain was absolutely required for this, or at least some sort of a primitive neuron system with some sort of an electrical charge responsible for the signals. But a lot of modern studies are discovering something entirely different. In some of the future videos we'll actually discuss the idea of intelligence in bacteria, which has also been discussed in many papers. But as the study of the slime mold shows us, intelligence seems to arise even if there is no electrical stimulation, electrical signals, or neurons. At least primitive intelligence that's able to solve simple problems and is also able to remember things. But I guess in this case you can still make certain analogies between what slime mold becomes when all of these cells come together, and to some extent a typical brain as well. For example, if you actually look at what the mold is doing to move around, you'll notice that it actually pulsates extremely quickly. And by pulsating, which involves a lot of expansion and contraction, it's able to effectively propagate across really large regions, but only in a direction that's most beneficial. And generally, when the mold encounters some sort of a food source, like sugar, it actually starts oscillating much faster. And as it starts to oscillate faster, the entire organism sort of moves in the same direction. And this is extremely similar to the oscillations we normally detect in a typical brain. But in this case, you would refer to this as a hydrodynamic system, whereas our brain is electrochemical. And so one of the most recent experiments wanted to figure out what it's able to sense in the environment in order to determine certain locations of motion. And so in this paper you can find in the description below, the scientists wanted to investigate how various physical cues would change the behavior of the slime mold. And it turns out that the mold itself is able to sense various mechanical depressions and usually prefers to move toward a certain direction, which could also be related to some type of a memory or because the mold prefers to move toward a certain direction. So when there was slightly more deformation on one side compared to the other side, the mold generally moved toward this side. And just to test this, the scientists decided to disable some of the genes responsible for this mechanosensation, the ability to sense the mechanical structure around you. And today the scientists know that in animal cells, this type of mechanosensation is done by transient receptor potential channels. And these are the channels that essentially allow us to taste things, to feel temperature, and to feel pain. Basically, this is how we sense the environment around us. And in a lot of different experiments with flies, these receptors have previously been blocked in order to show that the flies stop feeling certain things. And so today we have different chemicals that are used as a kind of a blocker for these types of receptors. And when the scientists added these blockers into the slime mold, the same thing happened. It stopped sensing things, it started moving into random directions, which I guess has some implications. It implies the mold also seems to sense things, or appears to sense things. Now, does it feel things? That's of course another question. And that's not a question we can answer anytime soon. But the important revelations from all of these studies are really in helping us sort of understand that intelligence takes many different forms. And for someone studying astrobiology, it also means that we can hypothetically find all sorts of intelligences out there. It really means that the brain itself is absolutely not a requirement for finding intelligence elsewhere. With this 500 million year old creature serving as a perfect example of intelligence at work without having a brain. Which also means that we sort of need to redefine our definition of intelligence at some point in the future. But remember, it only acquires these extreme abilities when things are not going so well, when the environment around the mold is no longer able to sustain it. This is when all of the tiny amoeba come together, form a single massive organism, with some of the smaller molds then forming some sort of a large, massive blob-like formation. And so this is a result of a massive collaboration of billions of different cells, with some of the cells choosing to sacrifice themselves in order to allow other cells to survive. But I guess one question that a lot of scientists wanted to have answered is, what would happen to this mold in space, in zero gravity? And so what sort of behavior is it going to exhibit in microgravity? What direction is it going to prefer? Is it going to go sideways, or will it actually start forming three-dimensional structures? And so right now, several pieces of this mold are actually headed to the ISS. So this is something that scientists are currently going to be investigating in the next few weeks, in the next few months. But it also sort of serves as a very interesting school experiment. The scientists in France are also distributing the same pieces of the same mold to various schools, to various high schools, in order to create the copy of this mold in various environments there, basically to encourage students to learn more about it, while also realizing that exactly the same mold is in space doing its own thing. And so this is definitely going to be a pretty interesting study to follow, and something we'll talk about in some of the future videos once we have more detail. Hello wonderful person, this is Anton, and today we're going to be discussing this very new study that just came out that seems to create even more mysteries for the so-called Fermi paradox. The paradox of not really seeing any extraterrestrial superintelligence somewhere out there, traveling the galaxy, discovering and colonizing new planets, and forming these large complex societies that should be visible from very far away distances. Because if we ignore the media, and if we actually look at some of the scientific analysis from, for example, Search for Extraterrestrial Intelligence community, or a lot of other scientific papers, including this most recent paper that came out only a few months ago, which took a look at roughly around 60 million different star systems out there, we'll once again find ourselves in a situation that suggests no one is really talking to anyone else. There doesn't seem to be a lot of super complex civilizations producing a lot of different types of communication, and, well, for the most part, at least for now, we seem to be alone. And so that is the nutshell of the Fermi paradox. But the most recent study that I'm discussing today, the one that as always you can find in the description below, goes a little bit further, because it sort of makes the paradox even more paradoxical. What this particular study investigated is the idea of the ability of alien species, a complex alien species, to propagate through a galaxy. And they've discovered that even using conservative values, a typical civilization that's already pretty complex should be able to spread through the galaxy, as you kind of see in this particular simulation, relatively easily. And they make a pretty strong argument and a pretty interesting analysis out of this. And so I figured this is a perfect opportunity to discuss this, and also to discuss some of the shortcomings of the study. But first, let's start right here. The visual representation of the famous Kardashev scale, created by the Soviet astronomer back in 1964. And according to the scale, there are three different levels of a typical civilization advancement. We have the Type 1 civilization, that's basically the planetary civilization that's able to use pretty much most of the energy from a typical planet. Then, once the limits of energy are reached, the civilization becomes Type 2 civilization and starts using the entire energy of the star system. At this point, it becomes what's known as the Type 2 civilization, and that's essentially where you usually find structures like the Dyson swarm, or the Dyson ring, or the Dyson sphere that allows the civilization to capture the energy of the star itself. And then, according to Kardashev, a civilization is going to reach the limit here as well and become a Type 3 civilization, and will begin using the energy of the entire galaxy. And so that's kind of how he back then thought about it, and to some extent this scale is still even accepted today, especially when it comes to the search for extraterrestrial intelligence. Okay, quick side note. I personally do not agree with this scale for one simple reason: bias, and also zeitgeist. Zeitgeist, if you've never heard this term before, refers to the idea of the spirit of time. Kardashev lived in the Soviet Union and he developed the scale in the 60s. This is when the country was growing bigger and bigger, it was building bigger and bigger projects, and it was also requiring more and more energy. It was quite natural back then to assume that it's going to sort of continue on the same scale, and at some point we're going to start using the energy of the planet, the energy of the solar system, and the energy of the galaxy. However, it's a very simplistic approach to how a civilization very likely advances. We cannot possibly predict or even understand how any of this happens. As a matter of fact, for the humanity at least, all of these advances are a very recent thing. We've lived without really developing almost at all for thousands of years and have only started to produce and also use these different types of energies in the last 100 years or so. But that's just as a quick side note. Let's move on. Let's go back to the scale because in this paper the scientists focused on two types of civilization. A type 2 civilization that then slowly becomes a type 3 civilization. The kind of a civilization that should be visible from really far distances if we were to use some of the modern techniques in trying to locate various signals across the galaxy. And so in this paper, which I found to be extremely fascinating, the scientists took a very conservative approach. First of all, no warp drives, no faster than light travel. And also no wormholes, no travel of any kind that sort of violates our current understanding of science. Which, by the way, of course, is its own topic in some of the future videos on the channel, so make sure to subscribe. So if there's no wormholes and no faster than light travel, how are the ships going to be traveling? In their study, they limited the travel speed at approximately 10 km per second, or, well, basically roughly around the same speed we would expect a typical spacecraft to travel from, for example, planet Earth to some other planet like Jupiter. In other words, they really sort of focused on making this as realistic as possible. And because of this, naturally, traveling will take a very, very long time. But in this case, they limited the travel time as well. Every one of the ships in their simulation was only allowed to travel maximum distance of 10 light years. That's slightly more than double the distance to the nearest star to us, Proxima Centauri. And none of the ships here were allowed to travel for more than 300,000 years, because after that the ship was considered to be lost and the mission was considered to be failure. Although 300,000 years is actually still a pretty long time, we don't truly even know if any of our technology can survive that long. On top of this, the migration ships, or the civilization ships, were only launched every 10,000 years. And upon landing, no civilization was allowed to last more than 100 million years. And so in a nutshell, we have a lot of slow-moving civilization ships, what you would call a generation ship, trying to colonize as many stars as possible, with one very important addition to all of this. These ships, these civilization ships, would only be launched if the nearby star came close enough for the ship to reach the star in time. Because we don't have any faster-than-light travel or any wormholes here, the only way for these ships to reach another star system was if the star system actually came close enough to the parent star. Which is actually a concept I recently mentioned in another video you can check out somewhere right there. And so here we have this really interesting scenario. And the question is, how well will it go? Are these civilizations going to go extinct, or is the civilization going to spread across the entire galaxy? And so here's what we have. We have the initial place right there, sort of similar to where our sun is located, and as these stars move around the galaxy, and as one planet after another gets settled, at some point, this becomes an exponential growth, and then within only a few million years, the entire central region of the galaxy is actually going to be extremely overpopulated, which by itself made this an extremely interesting discovery. Watch how fast all of this happens. The entire central region basically becomes full of these very interesting civilizations, all of them stemming from a single origin, and all of them very likely possessing the technology to communicate and to transfer signals and to very likely hear each other. But, as you saw from the previous study I showed you in the beginning, this is not the case for the Milky Way galaxy at all. As a matter of fact, no one seems to be calling back home and no one seems to be sending any signals. Although okay, not everyone. Do check out this other video about the signal we might have received from Proxima Centauri. But that's something we'll discuss in another video because there have been some updates. Anyway, so this is definitely not happening in the Milky Way, at least not right now. But it is a very interesting discovery, and especially interesting because of the way that the civilizations use the technologies available to us right now to spread across the galaxy. Now naturally we don't have any generation ships yet, and we're not really going to have a star next to us for another 2 million years, but if we wait long enough, the stars will actually come close enough. And one of the more important discoveries here is that Because generally speaking, the distances between stars in the center of the galaxy are much closer, and because there are more chances for a lot of stars to come close to one another, that's really why the central region here becomes so overpopulated so quickly. And so this study does suggest that we should be looking inside the centers of galaxies if we want to one day discover some advanced civilization somewhere out there. Although this does kind of go against some of the other studies that suggest that the center of a galaxy is typically a very dangerous place because of constant supernova and constant emissions from the central black hole that produces a lot of energy that can actually strip the planet of any life. On top of this, some of the shortcomings from the study are, well, the fact that they kind of believe a civilization can survive for 100 million years. Remember, the human civilization as we know it is at best a few thousand years old, although technically speaking the information age has only started less than 100 years ago. And so the assumption here is that we can survive long enough for a nearby star to get close enough to us so we can kind of jump onto it. But that is a pretty big assumption. Nevertheless, mathematically at least, this does present us with a very interesting model on how a civilization can hypothetically migrate through the entire galaxy and where we can potentially find a successful civilization somewhere out there. With the biggest predictor in this case being the star density. The more stars there are in a region, the more likely the civilization is going to be able to hop from one place to another. Furthermore, what makes this simulation particularly exciting is that this whole process here only took approximately 1 billion years. And remember, the universe is about 13.7 billion years old, and the peak of star formation and also the peak of formation of planets similar to planet Earth was very likely billions of years ago, so the chance that these existed sometime in the past is actually still there. We're just not sure if they still exist today. But I still like the approach they took in the study, with the idea behind colonization and civilization expansion being slow and steady wins the race. Instead of racing for a new star and instead of creating technology that allows us to travel faster than light, which might actually not even exist, in this case, this advanced alien civilization simply just waits long enough and then jumps onto the nearest star. But if something like this happened in the history of our own galaxy, there's a big chance now that a lot of different planets in the center of our galaxy are just filled with ancient ruins of various civilizations. It might have even happened more than once. At least according to this model and according to the simulations established by these scientists. Although it still doesn't change the fact that after observing many of these stars in the center of the Milky Way for many years now, the scientists still have not seen or heard anything. And so the Fermi paradox is more paradoxical than ever before. Hello wonderful person, this is Anton, and today we're going to be talking about a new intriguing paper with a very interesting title, Avoiding the Great Filter, a projected time frame for human expansion off-world. A paper that creates a model exploring a very simple but very intriguing concept. The concept known as the Great Filter that tries to answer the Fermi paradox. Where is everybody? Why is it that after decades of observing and listening to the universe, we still have not heard a single convincing signal indicating that it's extraterrestrial intelligence? Not a single sign or observation definitively telling us that aliens are living somewhere out there on another planet. And one of the resolutions of the Fermi paradox is known as the Great Filter. The concept originally proposed in 1996 by this wonderful person, an economist who essentially discussed this idea, suggesting that we most likely have already passed this so-called filter. The article that's also available in the description below that you can find right here. With the main idea behind the Great Filter being our misunderstanding of how life, complex life, intelligent life, evolves on various planets or across the universe. Hansen suggests that there is some sort of a filter, a great filter, that prevents any life in the universe from reaching a certain stage that we expect mathematically. And so in this particular case, he suggests that there might be a filter that we already kind of crossed, that many other civilizations crossed as well, that unfortunately leads to the complete destruction of the entire civilization. The filter itself could be absolutely anything and possibly present during any of the steps of the evolution of life. He lists some of the steps right here, but the actual filter could be in any of these steps, or even any other steps that are not listed. So in other words, Hansen himself does not know what exactly it is, but the fact that we're not hearing or seeing a lot of civilizations traveling the galaxy to him, suggests that the filter does exist and something stops these civilizations from developing to that point. But this is of course just one of the potential answers for the so-called Fermi paradox. But in this paper they go in a slightly different direction. First of all, they do make an assumption that although we haven't reached the great filter just yet, we have reached what's known as the window of peril. We've reached a stage when we have a capacity to completely destroy ourselves. Something that began right after the World War II with the development of the nuclear weapons. And within only a few decades, this window has increased in size. More and more things start happening, increasing the chance for a complete self-destruction. And in this case, it doesn't actually matter what it is, it's just the chances have increased. Simply because we now have so many more ways of destroying the entire world. Nuclear weapons, some sort of biological warfare, or anything else related to the climate change on the planet. But the scientists in the paper proposed the solution to avoiding the great filter, the solution that's been talked about before by a lot of different individuals. Turning our species into an interplanetary and interstellar species. If we do manage to find a way to travel across star systems, it will automatically make great filter a non-issue, and it will definitely prevent our species from being completely destroyed. And so in this paper they actually create a model that tries to predict the potential dates for various robotic missions and for various human missions to all sorts of planets and stars out there. And they use a very interesting proposition to do this. A concept that's somewhat related to Moore's law. The law that suggested that the number of transistors on microchips doubles every 2 years, as you can kind of see from this graph right here. And here the idea is pretty simple. Deep space missions are almost directly related to the complexity of computers and a lot of robotic systems. As this complexity increases over time, more and more complex missions are going to start becoming possible, with space missions becoming more and more complex as the time goes on and as we develop new technology. And assuming that we can survive long enough to become interplanetary and interstellar, at this point, the great filter is no longer a problem, at least according to the scientists in this paper. But their model also creates actual dates for various potential missions. Missions to Jupiter, missions to Saturn, and missions to some of the nearby stars. The first prediction here is in regards to Mars. They predict the first manned missions in 2030s. But this is of course not news to us because Elon Musk has already been talking about this, as were some of the scientists from China as well. And so a mission to Mars in 2030 is obviously expected. But by 2060s, their model predicts that we're also going to reach the asteroid belt, possibly an object like Ceres or Vesta. And since we've already reached these objects with the robotic missions, it only makes sense that this would be the next step. 10 years after, in 2070s, their model predicts the landing of humans on one of the moons of Jupiter. Probably not Io, very likely Ganymede or Europa. But 10 years after that, in 2080s, we're probably going to end up somewhere around Saturn. And in this case, it's probably going to be Titan. A manned mission to Titan by 2080s does sound pretty exciting. But being a mathematical model, things here do escalate pretty quickly, simply because this is a logarithmic function, and also because of the tremendous distances to various stars out there. So for example, to reach the nearest star, Proxima Centauri, for some sort of a robotic probe is not going to take too long. It might actually be ready in a few years from now. But a manned mission is a completely different story. The first human being to arrive to Proxima Centauri is not going to leave Earth until 2250, according to their model. So roughly in around 230 years from now. Now slightly farther away we have this really exciting system known as Tau Cetus. There's an older video somewhere right there about it. This system is farther away, so the first robotic mission might be launched in 2030s. But the human mission is not expected until 2270, so 250 years from now. And then we have the famous TRAPPIST-1 system with its 7 beautiful terrestrial planets. But because this is at a distance of about 40 light years away from us, the robotic mission might launch in 2040, so in about 20 years from now. But the manned mission is not going to happen until 2300s, 280 years from now. But being a model, it also predicts some of the farther distances as well, including a mission to the center of our own galaxy, the center of the Milky Way. And although we could probably launch a robotic probe in 2050, the manned mission is not going to happen until 2400s. And this region might be super interesting to visit one day, simply because of the other paper they mentioned in their study. The paper we discussed on the channel as well, somewhere right there as well, that suggests that the most likely location for super complex civilizations is most likely to be somewhere at the center of the Milky Way galaxy, because of the other mathematical model that was performed in that paper. And so reaching that region might actually help us discover a lot of different extraterrestrial civilizations, at least according to this model. But my problem with the model is that everything here seems to be a little bit simplistic. First of all, this model naively suggests that we're going to be totally fine and advancing as normal for the next 300 years. At the moment, a lot of signs sort of point to the other direction. Unfortunately, at the current rate, things are not going to be well for humanity in the next 50 years. Second of all, this model relies on the idea of Moore's law and expects the technological advancement, just as Moore's law, to continuously double every 2 years. But when it comes to Moore's law, unfortunately we know we have reached the limit, simply because of the sizes of things we're talking about here. In this case, what you're seeing is the increase in the electron density, with the electrons suddenly being able to jump from one point to another due to the quantum tunneling effect that starts happening when the actual transistors get too small. So the Moore's law is no longer law. The size of the transistors can no longer become any smaller. And using a similar analogy here, it's quite possible that the human space exploration might also peak at some point. Not just space exploration, any kind of development when it comes to technology. And although the science fiction movies would expect us to believe a lot of different advancements, including faster than light travel, time travel, and all sorts of advanced amazing technology that could exist one day, the reality might be different. We don't really know if at some point technology is just going to peak completely. Just like the transistor development with Moore's law. Lastly, even now, we have no idea how to travel in space over long distances. We've obviously landed on the moon, but landing in another star system is a completely different story. We would have to have some extremely advanced spaceships that are able to survive really long trips without breaking down, and to somehow also preserve all of the life on those ships as well. None of this right now is even remotely possible. And so for now at least, this mathematical model is unfortunately just that. It's just a model. But the scientists in this paper do mention that this is just the first step, a first layer of a potentially much more complex model that's going to be developed over the years. And for all we know, maybe this right here is actually a huge underrepresentation. Maybe the reality is that we are only going to be making it to the stars in the next few thousands of years. But since the odds of survival of human beings here on planet Earth is currently not really looking that good either, we might want to actually put a lot of effort into this. We might want to find a way to avoid the Great Filter, and that's basically what the scientists are trying to push in this particular paper. At the moment, we're stuck here on Earth, but to survive longer, we might want to start looking outside of this planet. We might have to become an interplanetary and an interstellar species, and this could be essential for the survival of the entire civilization. And that is definitely something I agree with, but something nobody has a solution to right now. Hello wonderful person, this is Anton, and today we're going to be talking about techno-signatures, the signs of extraterrestrial intelligence somewhere out there. But what we're talking about is actually a very recent paper that was released not so long ago that tries to identify this very specific techno-signature we can use to try to find aliens somewhere out there, that here on planet Earth is actually something that we currently are trying to eliminate. We're going to be talking about pollution. In this case, the type of pollution that's present everywhere on planet Earth. Now, first of all, unlike some of the articles in the press that make you believe, NASA is actually extremely interested in discovering some sort of an alien life somewhere out there. As a matter of fact, a couple of years ago they held a really big workshop essentially identifying all of the potential techno-signatures we can look for, how to look for them, and even provided very specific detail on what exactly we can look for, how we can find it, and what sort of difficulties we can expect by looking at certain regions or by looking at certain particular things. And obviously also identified several difficulties and several biases that we can have when we can accidentally claim something is extraterrestrial intelligence, but in reality it's something that's not. The most famous example right now being Oumuamua, the extrasolar comet that visited inner solar system 3 or 4 years ago. But when it comes to trying to find different techno-signatures or basically trying to identify if there's really any other extraterrestrial intelligence out there, there's one specific thing that we know for a fact can lead to the discovery of alien life and potentially also extraterrestrial intelligence. The various chemical detections emanating from a certain planet or a certain object somewhere out there. Now, we've already discussed the so-called phosphine that was potentially discovered on Venus just roughly about a year ago. But even this particular discovery has already generated a lot of buzz and also a lot of contradictory theories. We still don't really know if phosphine was discovered on Venus, but phosphine, for example, is an extremely important gas that we know can only really be produced by either life or in some extremely complex environments. But phosphine does not guarantee any kind of intelligence though. So it's a great way for us to possibly discover alien life, but it's not a really good way for us to discover potentially intelligent life. As a matter of fact, phosphine is toxic to us. So if there is intelligence, or if there is intelligent life present on a certain planet, it's probably going to try to get rid of phosphine. There are, however, other gases we can look for. And in this case, there are two specific types of gases that we know for a fact, at least based on what we have here on planet Earth, can hypothetically be the sign of intelligent life somewhere out there. And both of these gases are to some extent the result of pollution on the planet. One of these gases, or actually one type of these gases, are the so-called CFCs, or chlorofluorocarbons. There's actually a few of them, as you can see in this particular list. And a few decades ago, these gases were responsible for almost causing our planet to lose the ozone layer, responsible for protecting us from the dangerous ultraviolet radiation. Luckily, a lot of governments around the world were able to combine their power and signed what's known as the Montreal Protocol that essentially banned the use of CFCs, and over the next few decades, the situation has improved dramatically. Although very recently there was a paper that suggested that certain regions, specifically China, I'm looking at you, still has certain emissions coming from certain regions. But that's definitely not enough for us to worry about yet, especially because a lot of these emissions were illegal and the government was not aware of them, and China has already promised to kind of fix this problem. But one thing about CFCs is that they're not produced naturally, they're only produced artificially. And because of this, we know that if we ever discover any CFCs emanating from a planet somewhere out there, there is something going on there for sure. At the same time, CFCs are also an extremely potent greenhouse gases, and could hypothetically be used by a species somewhere out there to terraform a planet. This is something that's already been proposed to, for example, terraform Mars as well. Although that's not something we can easily do just yet. But anyway, even though CFCs have already been investigated by NASA several times, there is another gas that's even more common that has recently been investigated in a paper you can find in the description below. Nitrogen dioxide. The gas produced in combustion, and that's actually what the scientists in this paper wanted to focus on. Specifically, they wanted to identify what exactly we should be looking for in these atmospheres of other planets if, for example, we discover that there is nitrogen dioxide there. Now, unlike the CFCs, nitrogen dioxide can actually be produced naturally through various geological means, but it's not really produced to the point where we can easily see it usually, and we normally know exactly how much nitrogen dioxide to expect on a certain planet like Venus, for example. But let's just say that we're looking at a distant star, and then as the planet passes in front of it, right at this point where the solar light passes through the atmosphere, we start getting certain different emissions suggesting that there is a lot of nitrogen dioxide in the atmosphere of this planet. Way more than the models predict. In this case, the only sort of reasonable explanation here is that it cannot be chemical, it has to be produced by an industry. This is the only gas we know, at least from our example, that happens to be an industrial gas. It's not a gas that's produced by life, it's also not a gas that's produced in really large amounts on planets, so large amounts of NO2 like here on planet Earth definitely indicates some sort of industrial civilization living there. And although things like lightning or even things like powerful volcanic eruptions can also produce some of this gas as well, in reality 80% of all the NO2 on the planet Earth currently is produced by humans. And it is a pretty bad gas, it's actually quite toxic, but nevertheless it still happens because we currently depend on various industries that unfortunately produce a lot of this gas. And what's more unusual is that in the lower regions of the atmosphere, about 10 to maybe 15 kilometers above the ground, nitrogen dioxide happens to be an extremely easily to see gas here. There is so much of it now that has accumulated over the years that if, for example, some other species were trying to discover if Earth is habitable, it would be very obvious. And because of this, we know that if we look at other planets and find this in their atmosphere, it's very likely that it was also possibly from the same types of origin. It is very unlikely for nitrogen dioxide to be accumulated in the upper atmosphere for long periods of time, which is pretty much exactly what the scientists in this paper argue. with the main purpose of the study being an ability to detect the NO2 signal and seeing if it actually represents some sort of a potential signal we can use to detect extraterrestrial intelligence. And long story short, the answer is yes, it can definitely be used as a technosignature. One of the more important discoveries from this paper is that, well, apparently, if there is some sort of a civilization living within about 30 light-year radius away from planet Earth, which by the way includes roughly around 500 or so star systems, and also possibly about 100 or so Earth-like planets, after about 400 hours of observation, we should be able to collect enough data on the atmosphere of this particular planet to know exactly if there is some sort of a combustion going on and if there is any NO2. And this is actually using modern technology, modern telescopes. So in other words, we don't really need any new telescopes to determine all of this. Moreover, certain stars, especially the ones that are colder than the Sun, such as the K-type stars or the red dwarfs, will actually produce much better signals, allowing us to definitively identify if there is any extraterrestrial intelligence. And also, since most of these stars do not produce enough ultraviolet radiation, they will also prevent the NO2 from breaking apart, and it will probably accumulate more NO2 in the atmospheres, which will then also increase our chance of finding something in some of these nearby star systems and nearby planets. But this study is obviously not perfect, and there are still a few problems that the scientists mention in the paper. For example, certain types of clouds or even certain types of aerosols can potentially represent very similar wavelengths to NO2. In other words, they can kind of fool us into thinking that we're seeing nitrogen dioxide, but in reality it's something completely different. At the same time, for us to detect these signals, it would kind of mean that these civilizations would have to produce NO2 for an extremely long time. I mean, when you think about it, here on planet Earth, we've only been producing NO2 for the past 100 years or so. This value represents 0.000002% of the total age of our planet. And this of course implies that statistically speaking, the chance of us detecting something in the vicinity within about 30 light years away from us is currently extremely low, like super low. So we shouldn't really keep our hopes up, but doing these studies allows us to definitely find ways of how we can find various technosignatures coming from other planets, and most importantly, it identifies factors preventing different types of biases and preventing very rash decisions of saying, hey, it's aliens, when in reality it was just pollution from something entirely different. So trying to eliminate these biases and trying to eliminate possible mistakes, and also doing all of these simulations in helping us identify what we should be looking for, can definitely one day help us discover some sort of an alien civilization somewhere out there. But we also have to always remember Carl Sagan's wisdom: extraordinary claims require extraordinary evidence. Hello wonderful person, this is Anton, and today we're going to be discussing the idea of extraterrestrial intelligence and the possibility of such intelligence existing somewhere out there in our galaxy. And all of this is going to be based on another study I discovered recently that as always you can find in the description below. But also before I start, I really wanted to talk about this. You probably know by now that I'm not the one to usually do any kind of a promotion, but in this case I wanted to make an exception. This absolutely wonderful science fiction novel by my friend Peter Codron from Brisbane, Australia, captures the essence of what we're going to be talking about today really well. And it's actually based on hypothetical questions that were asked by several astrophysicists and several science fiction writers a few years ago. This actually all started on Twitter, as always. Most of these things usually start on Twitter. And a lot of these questions were in regards to the famous Oumuamua, trying to essentially figure out if this was indeed some sort of an extraterrestrial probe or some sort of an extraterrestrial vessel, or if it was just a comet as a lot of scientists believed. And so without spoiling too much, Wherever Seeds May Fly explores this idea really well, and to the extent that I've never actually seen anyone do before. The book already has some stellar reviews and it's actually super fun. Anyway, so what exactly are we actually talking about today? And how does this all relate to Oumuamua and extraterrestrial intelligence? Well, a few months ago, this interesting paper came out that essentially used statistical analysis to estimate the amount of potential civilizations out there in the galaxy, but did so using several major assumptions. The biggest assumption actually being something that might help us resolve the famous Fermi paradox. You know, that paradox that started by this person right here, Enrico Fermi, who was one of the scientists working on the Manhattan Project, which resulted in the creation of a nuclear bomb. I remember reading the story, and basically the scientists working on the project once in a while had these philosophical discussions. And one day, Fermi looked up into the skies, pointed up, and said, "So, where is everyone?" That question has still not been answered. We still don't really understand why we're not actually seeing any other extraterrestrial civilization trying to communicate with us, trying to travel across different stars, and essentially having battles in outer space. Where is everybody indeed? And to try to come up with an answer for this non-existence of alien intelligence in outer space, at least us not seeing anything, the authors here take a very important assumption. All civilizations have a tendency to eventually self-destruct or self-annihilate. And whether it's because of some sort of a dramatic climatic change, because of some sort of a dramatic cataclysmical event that destroys the planet, or because this civilization reaches the point where it basically destroys itself, maybe because of the advances in technology, maybe because of some sort of a crazy AI, for some unknown reason. In other words, the main premise here is that all civilizations end the same. They end. We just don't really know when and how long it takes. And based on this premise of self-annihilation, the scientists then try to calculate how many possibilities we have for having civilizations out there right now, when the best time was for civilizations to exist in the galaxy, and also where exactly we would be most likely to find more civilizations, and thus possibly hear their communications as well. And some of the assumptions that had to be made in this study include, of course, the idea of the prevalence of Earth-like planets around Sun-like stars, in this case G-type stars, the prevalence of some really cataclysmic and potentially deadly events such as supernova happening nearby, the probability and also the time required for civilization to develop just enough to be able to produce radio emissions and communication. But also there had to be a numerical value for the tendency of all civilizations to eventually destroy themselves even if the conditions are absolutely perfect. And so this is kind of similar to the concept we have here on the planet in regards to empires. All empires eventually fall. And because of all of these assumptions, this is still a very hypothetical approach. And so assuming that life does indeed arise on various Earth-like planets around G-type stars, and also eventually does have a tendency to become somewhat intelligent and possibly even start communicating, this paper establishes very interesting parameters for when and where civilizations most likely existed the most in our galaxy. Roughly summarized in this image from the paper you can find in the description. According to the scientists, the most likely place to find the most civilizations even right now is actually somewhere in between planet Earth, or between the solar system and the center of the galaxy. What you're seeing being pointed at, that's basically the solar system. It's about 25,000 light years away from the center. Somewhere in the middle, right around the point of about 13,000 light years away from the center, that region right there has the highest probability of having the most Earth-like planets with G-type stars according to these scientists. But possibly not currently. The scientists believe that this was very likely the case about 5 billion years ago. In other words, 8 billion years after the creation of the universe, or possibly about a few 100 million years before Earth and the Sun were created. That's when that particular region in between Earth and the center had the highest number of galactic civilizations capable of interstellar communication and possibly even knew of each other's existence. But with the universe now being 5 billion years older, and with us being on the outskirts of the galaxy, that's when the chance of finding another civilization becomes much lower. According to the scientists here, we're basically like a frontier civilization, and we also sort of arrived to the party kind of late. In other words, a lot of civilizations that might have existed have long perished, with the highest number still being clustered around the same area around 13,000 light years away from the center, or about 12,000 light years away toward the center, toward this region you see right here in this beautiful time-lapse. But because this is a relatively far distance, it's about 12,000 light years away from us, it will be almost impossible for either one of the civilizations to know we exist or for us to know they still exist. And also, if they do exist, they're probably just really young or might not even exist yet. So in other words, even though the chance for their existence is higher in the middle of the galaxy, some of them might not have advanced enough to be able to communicate. But I guess another important implication from all of this is the fact that as the universe ages and as stars become older and older, the chance for an advanced civilization to become self-aware and to start to communicate, or to basically even reach the point where we are, is going to become even less and less prominent. So with time, with billions of years, there's going to be even less civilizations and even fewer possibilities for an advanced civilization to exist somewhere in the galaxy, with all eventually reaching the point where either something happens to their planet or they self-annihilate. And even if we make an assumption that Star Trek was correct and eventually humans will reach a point where we're basically just nice to each other and everything just works well and we get to travel across the universe, or in other words, if the chance for self-destruction is extremely low, statistically speaking from this paper, it still means that the majority of galactic civilizations have long perished for one reason or another. It's just been too long, 5 billion years. And any civilization that's still in existence today is probably still too young to do anything important or to be able to reach other stars or communicate with other species. And so essentially, the Fermi paradox here is answered with the idea that any civilization that still exists out there is just too young. It's not able to do anything that we expect an advanced civilization to do. And any Star Trek-like species able to travel across the universe has long perished for one reason or another. Another interesting discovery out of this paper suggests that the number of civilizations is currently still increasing, but in about 6 billion years or about 20 billion years after the creation of the universe, we're going to reach a kind of a balance where suddenly we're going to start having less civilizations forming and thus less opportunities for other civilizations to meet each other. And after this period, more civilizations are going to start dying out, suggesting that the chance for first contact is going to decrease even more. But here, it's also important to understand that the study is based on a lot of different assumptions. So obviously take this with a grain of salt. First of all, the assumption here was that the civilizations like ours, or really for this matter any reasonable galactic civilizations, can only form on Earth-like planets around G-type stars. For example, one of the assumptions was that about 11% of Earth-like planets around Sun-like stars will receive enough radiation to form liquid water and to thus allow life to exist. But one of the previous studies I discussed on the channel does mention that one of the reasons we have life on Earth is actually purely due to luck. And the video for this is somewhere right there. Anyway, so that's one assumption, but there are so many others. Like for example, one of the events that they consider to be a sterilizing event are supernova. But today we know that so many other events might have happened in our galaxy where they could have been sterilizing as well. One good example especially of potential civilizations close to the center of the galaxy are the super powerful events coming from the central black hole that created the Fermi bubbles. Whatever this was, it was so powerful that it might have sterilized a lot of galactic civilizations living in the area a few billion years ago. And so even though in this study the implication is that where we're located is actually kind of rare for galactic civilizations, a lot of other similar studies, especially ones touching on the idea of a lot of really powerful events happening near the center of the galaxy, imply quite the opposite. They imply that we got lucky by being so far from the center. And so in that sense, it's important to see this particular study as a kind of a best case scenario. A lot of things could have gone wrong for many different civilizations if they existed, which also implies that Earth and by extension the humanity itself might have got super lucky being where we are today. And also according to the scientists in the paper, in the best case scenario, the oldest civilization in the galaxy right now is about 500 million years old. But that's if nothing bad ever happened in the galaxy to that particular civilization. Now this of course would imply that that particular civilization would have a chance to, for example, launch something like a stellar sail or some kind of a probe to try to explore other parts of the galaxy, and maybe, just maybe, the mysterious Oumuamua might have been one of these probes. But on the other hand, depending on how long the object traveled across the galaxy, the implications from this paper suggest that the original civilization is probably long gone. With the main conclusion in the paper being the fact that if civilizations exist out there, they're probably just as young as ours. They're probably super curious about the life outside of their own planet, they're probably also curious to find other civilizations, but at the same time, they also have a propensity for self-destruction, kinda like humans. And so in that sense, maybe we'll hear from them one day, but chances are, at least according to this paper, based on our location, based on the age of the universe, we might actually never hear from anyone ever. And so for all we know, maybe all civilizations end up sending these extraterrestrial probes and then sort of self-annihilating for one reason or another. But just like in a lot of science fiction books, it doesn't mean that all civilizations are going to end up the same. Maybe, just maybe, at least one civilization out there is going to break the cycle. Hello wonderful person, this is Anton, and today we're going to be talking about yet another discovery of an organic molecule that's part of life, but this time discovered in space, far, far away from planet Earth. Something that was really mysterious and unusual a few decades ago, but something that apparently is not a big deal anymore because we found so many over the past few years. But this time this molecule is really important, because that particular molecule plays an essential role in developing these cells in our body. It's part of the cell membrane. A molecule that sort of looks like this, and is known as ETA or ethanolamine, one of many organic molecules that's absolutely essential for all life on Earth. But unlike some of the previous discoveries of various organic molecules, this one was found in the middle of a distant molecular cloud approximately 100,000 light years away from planet Earth. And because of this particular discovery and also a lot of other organic molecules that were discovered over the past few years, I figured it's important to put all of this together in order to help you understand why these are actually very important findings. And I guess let's start right here. You can find this link in the description below. There's already an entire list of various organic molecules and a lot of really complex molecules that have been already found around various asteroids, around various types of molecular clouds, or essentially just in outer space, outside of our own planet. And because a lot of those molecules are generally connected to life in some way or another, or are even basically responsible for forming life as we know it, discovering them in outer space in various clouds or around various asteroids directly helps us understand how common life could be out there and how likely life could form around some other object somewhere not so far away from us. But because a lot of these discoveries are more or less recent, from the last decade or so, we're still kind of early on in trying to understand all of this and then trying to sort of piece the picture together. One thing that doesn't surprise the scientists anymore though is just discovering all of these molecules out there. They've already discovered various types of amino acids, so things that produce proteins and your DNA, and they've already discovered a lot of other components, smaller components, that normally build bigger things inside of our bodies. And because of this, the idea of finding extraterrestrial life out there is becoming more and more of a reality as opposed to just being a science fiction. But the problem here is that despite discovering various organic molecules out there, and despite finding so many different elements, even around our asteroids or in other star systems, it's still not really clear to anyone how all of this can sort of form complex life. In simpler terms, it's as if we're basically finding all of these Lego pieces flying around space, and we are the Lego people living in our Legoland here on planet Earth. But right now we're trying to understand if a similar Legoland can form somewhere else out there on another planet. And most scientists believe that it's possible, but the actual mechanism is not really well understood. But this recent discovery might take us a tiny step closer. So first of all, this was discovered in a molecular cloud that usually ends up producing various stars after a few million years if it collides with another similar cloud. And inside of this cloud, the scientists have identified really huge amounts of these organic molecules. Now, because of this, they realized that there's gotta be something going on in the clouds themselves. They must be responsible for forming these molecules. And as a matter of fact, in their study they go even further. They establish the fact that it's much easier for these molecules to form inside these unusual clouds. They sort of refer to this phenomenon as dark chemistry. So now they believe that a lot of these chemical processes that essentially form these complex organic molecules must be happening around the molecular clouds first, where they essentially coalesce around tiny particles and start forming larger and larger structures, with some of these formations being relatively complex, something that probably happens on Earth as well. But the question here is, did it actually start on Earth, or did it first happen somewhere in outer space? So in other words, one of the questions here is, so that stuff we're made out of, did it actually come from outer space first and then was sort of combined into more complex stuff on the planet? Or did our planet originally create these Lego pieces? And at the moment, all of the signs suggest to the former. Pretty much all of the signs suggest to us that many of these molecules, many of these organic complex molecules, were first produced in outer space. And specifically, they were very likely produced in these molecular clouds. And so all of these tiny Lego pieces were already developed when the molecular cloud from which our solar system was made was still around and was about to start producing stars. Then, a few million and possibly a billion years later, all of these molecules started to coalesce into larger objects, into asteroids, into dwarf planets, and eventually produced actual planets like Earth. But all of these pieces were already there, they were already created, and very likely then started to combine into something more complex on the surface. Which of course implies that very similar processes could definitely happen around some other planet, somewhere out there in our own galaxy, in some other galaxy, or possibly even very close to us, as long as the similar conditions to planet Earth are provided. And that's kind of what the scientists believe right now. Now, in terms of this molecule, what exactly does it do and why is it so important? Well, the easiest way to understand how important this molecule is for life is to look at our cells, or really any cells out there. Every single cell out there is made out of the so-called phospholipid bilayer. It's this layer that you see right here, and if you were to zoom in here, you would see a series of organic molecules that form these unusual shapes, with the head itself sticking out to the outside and the tails sticking onto the inside. But if you were to look at this head a little bit closer, you would discover that it contains this molecule that I previously showed you. And this can actually be different depending on the cell and depending on a lot of other parameters. But this is one of the more common molecules that is usually used in those heads. But because this was discovered in this molecular cloud whose name you see right here, and because large amounts of it was discovered in that particular cloud, now the scientists really want to find out if it's kind of common to other clouds as well, or if it's really only some clouds that are lucky enough to produce just the right mixture of these molecules to then kickstart life. But this discovery definitely suggests that this molecule can easily be formed in space, and these clouds can contribute to the assembly of these molecules very early in the existence of the star system. And then all of these molecules would be delivered to growing planets, with possibly some planets getting just the right mixture of these early molecules to then kickstart life. Now that part is still not really well understood. As a matter of fact, we're probably still decades away from figuring any of this out. Nobody really knows what kind of kickstarts life. As a matter of fact, nobody's ever been able to create life from just molecules. The complex molecules were definitely created, but what happens afterwards? How do we turn those complex molecules into a functioning cell with DNA, with everything else? And so that's kind of what the scientists are trying to answer by looking for these molecules out there and hopefully one day discovering some other planet with actual functioning life on the surface. But I guess one of the more important discoveries out of this paper is that the scientists were definitively able to show that these really slow collisions inside various molecular clouds can effectively produce these organic molecules that can then hypothetically produce life. The concept they refer to as the dark chemistry. And more importantly, they showed that the chemistry itself seems to be a lot more efficient in these clouds compared to even a surface of a typical planet. The assembly conditions to form these complex molecules are perfect in these environments. And so, hypothetically, every single molecule responsible for a production of a typical cell could form in these dark chemistry conditions. And then on the other hand, they also discovered that a lot of the molecules we've been finding in various asteroids, and here we're of course talking about complex organic molecules relevant to life, also very likely did not come from the asteroids themselves and were most likely formed before the solar system. And so a lot of stuff we find in these asteroids is very likely billions of years old, formed inside the original molecular cloud from which our sun was formed as well. Which of course means that what you're looking at right here is like a factory of primordial life material. This is where very likely a lot of the organic molecules originally came from. Which of course implies that it can happen anywhere else in the universe at any point. But until we find life somewhere out there, for example on one of the moons of Saturn or Jupiter, we're not really going to get far in answering these questions. It's still super unclear how all of this is done and how the variety of organic molecules lead to the complex life we have on planet Earth. It's quite likely that a much more dense environment with a lot of liquid like water is required to do all of this, and to start forming more and more complex molecules with a lot of complex chemical reactions. But at this point, well, it's just a guess, nobody really knows. Back in 2017, the scientists using so-called pan-STARRS, which was a fast-response telescope used to detect certain objects like comets and asteroids, detected this unusual object known today as Oumuamua. And years later, we're still trying to figure out what exactly this was. Hello, wonderful person. Today, we might actually finally have a solution. A very sound scientific solution that does not involve aliens. But before I start, I actually wanted to briefly mention why we had this controversy and this unusual debate about the origins of this object. And without going into details about the object itself, the only reasonable explanation I see to all of this is, well, unfortunately, for the lack of better words, scientific ego. The idea of wanting to be that one scientist discovering something absolutely extraordinary somewhere out there and being that first person to mention it, to provide proof for it, and to then basically be in a spotlight because of this. Now, unfortunately, in science this happens quite a lot. And also, unfortunately, in science, because of this, there are two main problems. One of the main problems with this is that eventually this causes the public to lose faith and to lose any kind of confidence in scientific discoveries, in the scientific community, and in scientists in general. Second of all, the problem with this mentality is that this creates a kind of a race to try to be that one person to discover something incredible so that you can be in the spotlight. Which also often ends up in people making a lot of mistakes in the process and then basically becoming a kind of a pariah or just losing their job completely. Now that's not exactly what I wanted to focus on, but it's really important to understand that when trying to figure out what we're looking at, it's super important in science not to jump to conclusions, especially when those conclusions can be explained by any other reasonable means. And even though we all really want to believe in extraterrestrial intelligence, and a lot of us actually are convinced the aliens are somewhere out there, trying to explain a phenomenon that can be explained in different ways by basically implying that it's probably alien intelligence is actually a somewhat irresponsible thing to do. At least for scientists. It is totally okay if you're not a scientist though, but if you are in the scientific community, it is extremely important to be very prudent in investigating your claims and in trying to avoid turning a hypothesis into an actual fact, because that's what's been happening with a lot of new discoveries in the last few decades. Planet 9 right here being the other culprit. But anyway, despite all of this, I still wanted to really talk about this object, because the new paper in some sense is kind of brilliant. And in some sense it's actually extremely interesting to read what the scientists had to say. But first of all, let's actually talk about the shape of Oumuamua, because what I've been showing you so far is this really unusual cigar-like shape. But a lot of scientists today do not believe this was the shape at all. As a matter of fact, a lot of new studies, including the study I talked about a few years ago, determined that the shape probably looks something similar to what you see right here. A kind of a flat pancake-like shape, or in some sense it also looks like basically a bar of soap after you use it for a very long time. Which is actually an important analogy because we're going to come back to this in a few minutes. But unfortunately, because all of the illustrations so far have been made using this shape, I'm going to have to use this just to illustrate my point. So we know that this object came into the solar system moving at a velocity slightly lower than would be expected from a typical interstellar object. What this implies, according to the scientists, is that this object probably wasn't really traveling for a very long time across the interstellar space. The suggestion here being that it's maybe about 500 million years tops, possibly even less than that. We also believe that it originally entered the outer solar system roughly around the year 1605, so essentially in the beginning of the astronomy, and it's probably going to officially leave the solar system by the year 2430, moving at a speed of about 26.3 kilometers per second. Now, one of the more unusual features of this object was of course its light curve. For some reason, this is what the scientists observed, which they interpreted as the object tumbling around as it was basically moving through the solar system. But the actual shape has been debated ever since. At first it was a cigar shape, later on scientists actually worked out that it was probably more of a disc shape. But so far nothing really makes this object unusual. But then something happened that the scientists didn't expect. As they started to observe this object leaving the solar system, they realized that there was a slight deviation between the observed orbit and the expected orbit. Now for comets that's actually totally not unusual. We expect the comets, as they emit a lot of material from their core, generally start to change their orbit and trajectory just a little bit. And usually this is correlated with the cometary tail itself. But what made Oumuamua different is that the cometary tail was not observed at all. And so the trajectory here was changing, yet at the same time, the tail was not observed anywhere. And because of this, well, that's where this explanation came from. And honestly, at least scientifically, this still kind of doesn't make sense, because there are so many other better explanations, with 2 papers that you can find in the description below probably being the best explanation we have so far. And in the paper there are really only 2 main assumptions that are being made. One of them is that it was definitely a pancake shape, and the second explanation, well, it's actually in this image to some extent. It's the color of the object mixed with the idea of what it's actually made out of. It was not made from the same material as typical comets we detect, such as the famous 2020 Neowise comet, which usually are made out of different frozen gases, all sorts of water ices, and also carbon monoxide, carbon dioxide, methane, and ammonia. A lot of these gases are usually visible and also emit certain types of colors as we look at them when the sun illuminates them from the distance. But we also know that there are a lot of objects out there in the outer solar system, such as, for example, objects in the same vicinity and in the same orbit as beautiful Pluto right here, that actually are made out of something different. Something that gives Pluto this beautiful reddish color. That's nitrogen ice. A lot of this red stuff you see on the surface, that's basically nitrogen ice. And that's something that evaporates very differently from the material that usually is present in most comets. And so, in other words, what the scientists in this paper imply was that it was actually a chunk of nitrogen ice, most likely separated from some distant Pluto-like object in another star system. Or in other words, it was basically a chunk of exoplanetary Pluto, or exopluto, exodwarf planet, whatever you want to call it. With a very elegant explanation provided in this illustration right here. So all of this starts possibly about 400 to 500 million years ago, as something collides with a distant Pluto-like object in another star system and essentially ejects this really large piece that eventually escapes into the outer star system, or essentially into the interstellar space. Now, originally this chunk was probably more circular in shape, but with time, because of the way that nitrogen interacts with cosmic rays, for example, it slowly eroded through various types of radiation, and in some sense, just like your soap in your bathroom, eventually becomes kind of flattened. Now, you've all seen this before. As you rub the soap around and as you basically use it over the next few weeks, it eventually becomes really flat. Same mechanism applies to what happened here. It then enters the solar system, approaches the closest point to the sun in 2017, and then eventually makes its way out of the solar system, and just a few months later we're able to see it with a telescope. And those deviations from the orbit were very likely caused by the evaporation of nitrogen ice from the surface. And it just so happens that, well, as nitrogen evaporates, it doesn't actually produce any kind of tails at all. We would not really be seeing this anywhere. And on top of this, because this was a chunk of ice from another dwarf planet, the implication here is that it was probably also a lot more reflective, and thus the object was probably much smaller than we initially assumed. And by being so much smaller, the amount of emissions coming from the object were able to deviate its orbit a lot more than initially predicted. And so by being a reflective chunk of ice, and by also emitting a lot of nitrogen in the process, a lot of the observations of the orbital changes can be easily explained and are easily explained in this particular paper. As a matter of fact, this explanation seems to provide the exact match to everything we've seen so far. Even the reflectivity of this object was very similar to the reflectivity we usually detect on objects like Pluto and Triton. So in other words, it was definitely a chunk of a dwarf planet or some sort of an object from another star system, but from the same region where we usually discover dwarf planets. And the object itself probably came from a relatively young star system that was still being developed, something that, just like the solar system in the beginning, experienced a lot of different collisions, which is why this object was probably released in the first place. Which of course also confirms that, well, it seems other star systems also have their own dwarf planets that are probably made of the same stuff as Pluto, Triton, and a lot of dwarf planets in the solar system. But with recent estimates suggesting that approximately 7 such objects should be passing through the solar system every single year, we now have a great opportunity to possibly discover another one of these objects and study it in a lot more detail before it disappears once again. And despite all of the other assumptions and controversy that this object created, it still is one of the most interesting discoveries of the last decade, and is definitely one of those discoveries that a lot of scientists will be talking about years to come. But probably not because of this. Definitely because of what's in these two papers that you can find in the description below. But unfortunately for now, that's kind of all we know. Although for me personally, this explanation is more than enough. It provides all of the necessary answers and provides all of the explanations to everything that was seen in this unusual object. Hello wonderful person, this is Anton, and today we're going to be talking about this new study that seems to have identified a completely new type of a planet that could potentially be habitable. And in this case, the scientists refer to these types of planets as the Haitian worlds, with a lot of these worlds falling under the category known as the mini Neptunes. But the most exciting part of this particular study, and in this case the most exciting part of the analysis, is that there seem to be so many of these planets out there, with some of them being the most common planets we've discovered. So this is actually a pretty interesting study and a pretty interesting analysis. And so let's start with the idea of what these planets are like and what probably happens on their surfaces. Starting with this right here. As of today, we've confirmed 4,472 exoplanets, with nearly 8,000 other planets being candidates, meaning that they're probably going to get confirmed at some point in the future. And of these thousands of different exoplanets discovered so far, some of them have actually been much easier to find and some of them kind of stand out. And a lot of those very common exoplanets don't seem to exist in the solar system either, so we don't really know much about them. And generally a lot of these exoplanets are divided into the rocky planets, with the hot ones being referred to as the lava worlds, all sorts of different gas giants such as hot Jupiters, but then right here in the middle we have these ocean worlds, ice giants, mini Neptunes, and super Earths. And these are the planets that have been really fascinating because there seem to be a lot more of them than a lot of other planets. Way more than gas giants and even more than typical terrestrial planets or rocky worlds. But because these types of planets do not exist in the solar system, the only way for us to figure out what's happening on their surface and inside of these planets is through various hypothetical studies or through various simulations using supercomputers. Nevertheless, they do represent some of the most exciting exoplanets we've discovered so far, with one in particular already showing signs of potential habitability. The exoplanet located about 124 light-years away from us, known as K2-18b, an object that we've discussed on the channel previously, and a planet where the water vapor has already been discovered in the atmosphere, that also happens to be in the habitable zone of the star system, and that might potentially represent the prototype for these types of exoplanets, the Haitian planets. Planets that seem to be habitable, but represent something completely different from planet Earth. And that is pretty much the focus of the paper that you can find in the description below. They investigate these planets mathematically, and sort of discovered that, first of all, these planets do seem to possess habitable conditions in certain parts of the planet, while also discovering that these unusual planets might be some of the most numerous habitable worlds out there, which actually makes this really exciting. But in order to classify these objects and a lot of these planets as habitable, we of course are relying on the idea behind planet Earth. The assumption here is that the habitability comes from liquid water, so these objects have to possess a way to maintain liquid water for millions and billions of years. Which is of course why objects around Saturn and Jupiter such as Ganymede, Europa, Titan and so on have generally been seen as good potential candidates for potential life living somewhere inside those planets, somewhere underneath the ice caps inside the liquid ocean. But in this particular case, through analysis, the scientists have also determined that certain mini Neptunes, or these objects that are generally less massive and usually smaller than Neptune, yet are way bigger and more massive than planet Earth, given just the right properties, will actually contain quite a lot of different ways to maintain liquid water inside the planet underneath the thick atmosphere. Or in other words, if we were to somehow see through the atmosphere, we would probably find ourselves in a very interesting situation with a very large liquid ocean and potentially a lot of possibilities for life to form in these oceans. Oceans that would be tens of if not hundreds of times larger than the oceans on planet Earth, with the atmosphere being very different from planet Earth as well, probably very rich in hydrogen and certain other elements. Despite of all of this, the best representation of K2-18b, the prototype for these Haitian planets, at the moment makes it look like this. It's essentially an extremely large and very massive ocean world. And here's how it compares to planet Earth. With most of these planets being generally about 1.6 to maybe about 3.9 times larger in size than planet Earth, and the total mass being about 5 to 10 masses of planet Earth as well, so more massive and larger in size. With K2-18b being exactly 2.6 times larger and about 8.6 times more massive than Earth. But since it's located in the habitable zone of the planet, and since water vapor has already been discovered around this particular planet, this makes this one of the more interesting planets discovered out there. But according to the study, definitely not the only such planet, and a lot more have already been discovered and have already been confirmed, suggesting that this could definitely represent a completely new class of habitable planets that we should be exploring in more detail. Although trying to define exactly what the properties of these planets are is still a little bit difficult. So in this paper, the scientists believe that most of them are probably not really super-Earths. They're much bigger than super-Earths, but much smaller than mini-Neptunes. In other words, they represent a completely different class of a planet, with the maximum suggested size for these planets being about 2.6 size of planet Earth, and about 10 masses of Earth, because after this they probably turn into mini-Neptunes. At the same time, the temperature on these planets can actually be pretty high, simply because of very high pressures on the surface, and because some of them are a little bit closer to the parent star. The atmospheric temperatures can be up to about 200 degrees Celsius, so technically past the boiling temperature of water. But because of the high pressures on the surface, possibly up to about 1000 bar of pressure, the water can maintain its liquid form, and deeper in the water, the temperature will actually decrease, creating very comfortable conditions deeper in the oceans where life can actually easily evolve. But at the same time, these planets do vary quite a lot. For example, some of these planets will be tidally locked to the star. They will always be facing with the same side. And these dark Hycean worlds, as the scientists refer to them, will actually have very different conditions on the surface, potentially even more habitable than some of the other planets. At the same time, some of them will be farther away from the star and will actually form what's known as the cold Hycean planets. In this case, probably being somewhat similar to Europa, Ganymede, and Titan, which overall creates quite a diversity for various habitable conditions, with many of these planets already meeting the qualifications for being the Hycean planet. And even though previously we mostly focused on terrestrial habitable zone, or basically looking for planets that are similar to planet Earth that are in the habitable zone of their stars, the main suggestion in the paper is that the Hycean planets represent a much higher chance for us to find alien life somewhere out there, with quite a lot of these planets already fitting into the category. On top of this, because of their size and because of the thickness of their atmosphere, some of the future telescopes, such as the James Webb Telescope, will have a perfect opportunity to look for various biosignatures in the atmospheres of these planets. And the scientists in this paper identify several such biomarkers, with some of them visible in this graph right here, suggesting that a lot of these planets should really be the focus of future studies, in terms of this search for extraterrestrial life at least. And so any kind of a biosignature or any kind of emission coming from potential life here would be a lot easier to find around a lot of these Hycean planets compared to some of the terrestrial worlds we've found so far, with quite a lot of candidates that have already been found being within about 150 light years away from planet Earth. And because of the atmospheric composition of these planets, they actually maintain their habitability in a lot of different regions around the star. They can actually maintain liquid water even if they're really far from the star, simply because of the pressures created by the hydrogen. Suggesting, of course, that even at really far away distances from the star, they'll still technically be habitable and have liquid oceans, which makes this for a pretty exciting type of planet and will most likely create a lot of exciting opportunities for future studies. But in this case, we're probably going to be looking for very different biosignatures, mostly because it's expected that the life, if it exists here, is not really going to be producing much oxygen or a lot of other similar compounds to planet Earth. The chemical emissions from the life here would be very different, with potential signs of life being things like methyl chloride, dimethyl sulfide, and a lot of other non-oxygen life-based compounds that we normally find in some of the depths of the oceans on planet Earth. And so life here would be obviously extremely different. It would be surviving extremely hot conditions, it would also be living in very highly pressurized conditions, but I guess not so different from some of the regions in the oceans of planet Earth. But in regards to potential extraterrestrial intelligence on these planets, that's a completely different question. Since we don't even understand how intelligence formed on planet Earth, we're probably not going to be finding anything anytime soon. Hello wonderful person, this is Anton, and today we're going to be talking about our attempts to find alien life somewhere out there. But more specifically, we're actually going to be discussing two very intriguing scientific techniques that might allow us to discover some kind of an alien life somewhere out there, using a very interesting property of light and also using the chemical composition of certain molecules. Something that you can learn more about from the two scientific papers in the description below. But what exactly is this for, and why are the scientists doing all of this? Well, one of the main reasons is because we, even today, do not have a very good way of detecting alien life. Here we're talking about on other objects such as different moons and different planets. Furthermore, we've had several cases of potential signs of life discovered, yet at the same time a lot of scientists today believe that no life was found in those particular cases. The most famous such example can be of course seen right here in the meteorite that came from Mars. This is a meteorite known as ALH 84001, and because of this formation that looks like it was created by some sort of a life, back in the late 90s, Bill Clinton officially announced that we've discovered life on another planet. But it took less than a decade to basically prove this wrong. Turns out something that looks like potential life does not necessarily mean life at all. This was a chemical reaction that created these unusual formations. And so if something looks like life, it does not necessarily mean that it's life. On the other hand, what about chemistry? Well, when it comes to chemical reactions, the best example is from the 70s from the Viking probe. During the chemical reaction on Mars, it did potentially detect signs of something creating chemicals that shouldn't really exist there. But even today, the scientists mostly believe that this was naturally produced by something else, not life at all. Which puts us in a very difficult situation. If we cannot identify life by looking at it and by trying to see if it looks like life, and if chemical reactions do not really necessarily mean it's life either, what can we possibly use using satellites, possibly telescopes or, I don't know, spacecrafts, to try to find life somewhere out there? Is there some sort of a definitive way for us to look at something and say, okay, that's definitely life right there? What possible techniques can we use for this? Well, today I'm going to be discussing these two different techniques that scientists have recently identified. One of them is still chemical in nature. It does use the idea of chemicals, but it goes a step further. It actually looks at something they refer to as molecular assembly, or MA for short. With this picture here sort of showing us what MA represents. This MA number depends directly on the number of connections made inside a molecule. The more connections, the higher the MA number is going to be. For example, for penicillin right here, the number is 17 because that's what the molecule of penicillin looks like. For tryptophan, it's 12. And for the very important molecule of life known as ATP, MA is 21, with the final molecule sort of resembling this. And this principle of molecular connections is sort of based on the idea of the assembly theory. And it's a very interesting idea because first of all, it's falsifiable. There's a way for us to prove it wrong, so it is very scientific in nature. And second of all, it depends on the principle that only life can produce molecules with high MA number, which to some extent presents an opportunity for us to define life a little bit better as well. And so in this case, large molecules with a lot of connections, according to this idea, will only be produced by life. It is extremely improbable, to the point of it being almost completely impossible, for these large molecules to be produced naturally by just some sort of a chemical reaction. Which of course makes this one of the most exciting tools for anyone studying astrobiology, for the scientists trying to find life somewhere out there on other planets. But how did the scientists behind this paper test all of this? Well, they used a database that contains roughly around 2.5 million different molecules with various types of origin as well. And for their study, they took a random sample of about 100 molecules, and along with the scientists from NASA, were then able to create a relatively accurate analysis, establishing the MA number for these molecules and also trying to compare it and correlate it with their origin. For example, they had some samples that were originally discovered inside different meteorites. They also had several samples that were millions of years old and also came from a lake sediment. And then they also had samples that were completely abiotic, not produced by life. And then by plotting this on the graph, they tried to establish which of these samples maybe came from life and which of these samples were definitely abiotic, not produced by life. And so for example, these samples in red that you see here, these were just chemical reactions, including some of the chemicals that were produced during the famous Miller-Urey experiment. This was of course the famous experiment that tried to establish if you can form life, or technically life particles, by using very simple compounds and very simple molecules. The samples in blue here represent something that was actually not alive anymore. Specifically, this was from yeast that actually was baked at about 200 and 400 degrees Celsius. And some other parts here were actually completely inorganic as well. But the most interesting results are this right here in navy and these ones right here in green. Some of these ones were from different fossils, whereas all of this was from living organisms, which allowed the scientists in this paper to establish a sort of a threshold. At some point when a molecule reaches a certain complexity, it is very unlikely or practically impossible for this type of a molecule to be formed by anything but life. According to them, the chance was like 1 in 100 billion trillion, and that's of course an extremely low chance of these molecules not being life produced. But where exactly is that particular threshold? Well, this is just a preliminary result from one study, but by doing various correlation studies, they seem to have established it at around maybe 15. So in other words, if we discover a complex molecule somewhere out there in the universe, even possibly on Mars or maybe our own moon, and we discover that its MA, or number of connections, is 15, the chance of that molecule not being produced by some sort of life is super low. It is most likely produced by some sort of a life somewhere out there. And by doing more analysis using this particular technique, we might even find a way to finally define exactly what life is on planet Earth as well. Mostly because we don't really have a very good definition of life to begin with. And so it will definitely help us understand how the chemistry of life works a little bit better. Oh, and by the way, in order to detect these molecules on, for example, some distant object somewhere out there, let's just say a moon or a planet that we've discovered, in this study the scientists have also worked out a pretty interesting technique using the light spectrometry from various molecules that can help the scientists looking at various planets to identify the MA of a certain molecule or some really complex compound found in the atmosphere of some alien planet somewhere out there, which could actually even be light years away from us. So this definitely makes this a pretty exciting technique. But then there's also the second technique discovered by another team, which uses a very different approach but also has really positive results. But instead of using chemistry and complexity of chemical molecules in terms of the actual connections, they used another really unusual property of pretty much all life on our planet. The property that you see right here, the property that's known as chirality or handedness. With this right here being a visual representation, just like we have a left hand and a right hand that in some sense represent a mirror image of one another, a lot of complex molecules in our bodies and everywhere around us also happen to have this chirality or handedness as well. There's a left-handed molecule and a right-handed molecule. And for many years now, scientists have known that a lot of molecules inside our bodies, including of course DNA, have very specific chirality or handedness. As a matter of fact, most molecules and most proteins in our body depend on chirality to function properly. So for example, if a certain protein as it's being created comes out as left-handed instead of right-handed, it's not going to function at all, or as a matter of fact, it might even cause some problems. And so for example, when it comes to amino acids, they're all left-handed in our bodies, whereas sugars are right-handed. But that's of course on our planet. On some other planet, maybe it's actually the opposite. On the other hand, we have some ancient organisms on the planet that can actually convert left-handed into right-handed and vice versa, so there is still a lot of questions that are not really answered here. Although when it comes to chirality, the reasons behind it on Earth might have been answered in one of the previous studies in the video that I made somewhere right there that discusses this idea from the perspective of the cosmic radiation. But either way, chirality or handedness is definitely a characteristic of a living organism. Or you can also refer to it as a biosignature, something we can use to detect life on other planets. But how can we possibly do this? Well, it turns out that if you were to shine light and to try to catch reflections from various organisms that possess chirality, the light is going to be returned with certain polarization. Or basically, the light as it sort of reflects from some of these molecules will come back twisted compared to what it was before. This is what we refer to as the polarity of light. And so by measuring the amount of polarization of light in a certain location, we can actually establish if there is life in that particular region or if there's nothing there. And this is exactly what the scientists behind this paper were successful in doing by literally trying to measure this from up in the air from a helicopter. And so here they took a very complex polarization camera on board of a helicopter and then flew around collecting various types of data looking at various locations underneath. And just like with other similar experiments these scientists conducted before, they were able to definitively see where, for example, really large patches of grass were. They were also able to establish where the forests were, where the urban environments were, and where there was just water. All of which was done by flying at a relatively high speed, approximately 4 kilometers above the ground. And so they essentially used this advanced new device that they refer to as the spectral polarimeter. They were definitively able to see where life was present and where life was not present. At least when it comes to larger patches of land with a lot of grass and a lot of forests, compared to, for example, just a simple road where nothing was detected. And although this is definitely a tool that can be successfully already used in, for example, agriculture, forestry, or to possibly study lakes and oceans, a much more exciting opportunity here is to try to apply these techniques to some distant planet or distant moon somewhere out there. If we detect a lot of polarized light coming from a very specific location around a certain object, and then on top of that, if we also discover a very complex molecule in this region with a very high MA number, this would almost certainly mean we found life on another planet. Although first we would have to test this from, for example, International Space Station and possibly develop techniques where we can actually detect all of this from space but here on Earth. And so by conducting these experiments once again, but from a space station, we'll be able to develop these techniques even further and possibly one day find an extremely efficient way of looking for life on other planets and finally discover something out there after all. Although at the moment the scientists suggest that it would still require a very long amount of observations, possibly hundreds of hours of looking at the same planet, in order to establish if the polarized light coming from the planet is indeed created by life or by something entirely different. But this is of course something that the scientists will hopefully be able to answer in some of the future studies. Hello wonderful person, this is Anton, and today we're going to be talking about biosignatures and possibly even technosignatures. The idea behind being able to detect life somewhere out there outside of planet Earth. But I wanted to start right here, Venus. This is actually what Venus looks like when you remove all of the atmosphere. And as you probably remember from around a year ago, there was a lot of excitement about Venus, mostly because of the potential discovery of what's known as phosphine, the somewhat toxic gas that's usually produced by life here on Earth, and that is sometimes also produced in some really extreme conditions on Jupiter and Saturn. Now, whether the phosphine was really detected or not, that's really the question for another video, but the idea of finding these biosignatures on other planets is one of the most exciting topics in what's known as astrobiology, trying to discover something out there living on another planet far away. Now, in the past few years, NASA and a lot of other scientists have already proposed a lot of different technosignatures that's for finding extraterrestrial intelligence somewhere out there, and they've also identified a lot of different biosignatures as well. But a study that just came out might have identified another really important one, something that a lot of scientists kind of thought about, but never really thought about it in that way. And that's a compound or a molecule known as isoprene. A molecule that sort of looks like this, with the general formula being C5H8. And just like methane, isoprene is an extremely abundant organic compound here on the planet. And it's so abundant, as a matter of fact, that even we produce it all the time. Even as I'm speaking to you right now, I'm breathing out a lot of isoprene in my breath. But there's a big chance that you might have never heard of isoprene, mostly because it's not really a compound that's normally talked about much, even though it is absolutely abundant everywhere. But we've all used stuff made from isoprene, even when we were little. Isoprene is essentially what we refer to as natural rubber. It's that stuff that's produced from the trees in several countries around the world, with the biggest producer I believe being Indonesia, and it's basically that white stuff you see coming out of the tree. Or to be more exact, this is known as latex, and inside of it there's quite a lot of isoprene. But even though this might look like something that we never really experience ourselves, it turns out that isoprene is actually everywhere around us. Every single tree, every single bush, every single plant, and a lot of different animals produce isoprene all the time. And what's even more surprising is that as much isoprene is produced by various things on Earth as methane. And just like methane, this is what's known as a secondary metabolite. Or in other words, it's produced as a kind of a leftover from some of the reactions. But most of the isoprene does come from trees. Forests, and specifically deciduous forests, seem to be the biggest producers of this molecule. Now, it's also produced by bacteria, it's also produced by animals, and a lot of other plants, but forests produce the largest amount of isoprene on the surface. Which is really interesting because the majority of the so-called secondary metabolites for animals usually come out as methane, whereas for trees it seems to be isoprene. But since it seems to be produced by a huge amount of different animals, different plants, and a lot of different things on the planet, it sort of makes sense to assume that isoprene might actually have this function somewhere else out there on another planet where life might evolve as well. And because isoprene is just as abundant as methane, it should also be relatively easy to detect it. But there is a small problem, at least with isoprene on planet Earth. Isoprene does not last very long when there's a lot of oxygen around. And so even though a lot of isoprene is released by trees and by a lot of animals, it usually doesn't last very long as soon as it comes into contact with oxygen and it turns into something completely different. But what if we're looking at a planet that doesn't have any oxygen, such as the primordial version of planet Earth? Those planets, if they do have a lot of early life on them, might actually suddenly have a lot of isoprene in the atmosphere as well. And because of this, scientists in this particular study that you can find in the description below realized that unlike on Earth, where isoprene is broken down into all of this other stuff you see right here, on these other distant planets, especially if they have early, still developing atmosphere, where life might have just started or maybe never evolved photosynthesis to produce oxygen, there might be a lot of isoprene in the atmosphere of those planets. And since, unlike for example phosphine, we don't really know of any inorganic ways of producing isoprene, it means that if we find any molecules present in the atmosphere of these planets, or let's just say we find some molecules present in the atmosphere of Venus, it will definitely mean that life is producing it here and not volcanoes, not some strange chemical reactions. And so I guess in some sense it's great news. We should probably jump onto this and start looking for isoprene on other planets. But it's not that easy. Mostly because it's still very difficult to detect. The scientists in the paper also mentioned that we need at least 10 times more isoprene in the atmosphere of a planet we're looking at before we can even identify its signatures using modern telescopes. Now they do mention that some of the future telescopes like James Webb Telescope or the Nancy Roman Telescope might be able to identify these signatures much easier, but at the moment we still need to have much stronger signature before we can find anything. At the same time, unfortunately, isoprene has a very similar signature, and we're talking about spectroscopic signature, to some of the other organic molecules, including methane. And actually several other hydrocarbon molecules do seem to possess a similar signature to this. With the basic comparison visible right here, the black is isoprene, with the other molecules represented in different colors. And so determining if what we're looking at is isoprene is still a bit of a challenge. But once again, future telescopes, especially the Nancy Grace Roman Telescope that's going to become operational in 2025, are going to have enough power to allow us to definitively say what it is that we're looking at. But chances are that one day we might actually find a planet somewhere out there with a lot of isoprene in its atmosphere. And what exactly isoprene is going to be doing in that atmosphere, that's of course a question we cannot answer right now. For example, we know that on Earth it does tend to form this somewhat strange, somewhat transparent liquid that does have a tendency to evaporate pretty quickly. But in certain conditions on certain planets, especially if there's no oxygen present in the atmosphere, it might be able to form lakes, it might even be able to form oceans, and might even have similar function to how methane functions on the objects like Titan, creating some sort of an unusual liquid cycle with rain, oceans, rivers, and everything made out of isoprene instead of water. And considering the fact that there's just as much isoprene on the planet as there's methane, as you see in this particular graph from the paper, I really don't think that this is a far-fetched assumption. For all we know, maybe even on earlier Earth, isoprene could have formed some sort of a strange liquid on the surface. But in case you're wondering what exactly does it actually do in the trees and why do we have so much of it everywhere, well, that's not really a question that's easy to answer. For example, for trees, it seems to be associated with some sort of a mechanism that prevents abiotic stress. For example, heat stress. With one explanation suggesting that when the temperature becomes really hot, maybe around 40 degrees Celsius, isoprene helps stabilize the membrane inside the leaf cell and thus protects the plant from various heat stresses. And then during nighttime, when the temperature is cooler, a lot of this isoprene is then released into the air. But interestingly, even we currently produce isoprene. approximately 17 milligrams per day of isoprene is released from your breath. Apparently it's the most abundant hydrocarbon inside our breath. And that is very difficult to explain. It's not entirely clear where it's coming from. It could be from our diet, it could be actually from the plants we're eating, but it also could be from the bacteria inside our bellies, or from something entirely different we don't currently understand. And so considering that it's so ubiquitous, it seems to be present everywhere, it doesn't really take much to imagine that there should be a planet somewhere else out there that is going to have very similar conditions with a lot of isoprene on the surface produced by various extraterrestrial life. Hello wonderful person, this is Anton, and today we're going to be talking about a pretty exciting but somewhat hypothetical topic in regards to Dyson spheres. And specifically we're going to be discussing this relatively recent paper that tries to identify and tries to analyze the potential existence of Dyson spheres around supermassive black holes. Could some sort of advanced civilization, such as what we would call Type 2 or Type 3 Kardashev civilization, potentially have an ability to create a massive structure around a black hole in order to absorb more energy for its own use? And more importantly, the paper tries to answer the question, could they physically exist? Or would a black hole completely destroy these structures? And also, if they do exist, such as around the central massive black hole in the middle of the Milky Way galaxy, would there be any way for us to detect them using modern technology? And short spoiler, the answer to all of these questions seems to be more or less yes. So let's start with the basics. Back in the 60s, the brilliant Freeman Dyson that you see right here published a few scientific articles describing a very hypothetical scenario of how a really advanced civilization could collect energy from their star. Something that we today refer to as the Dyson sphere, or depending on the structure, sometimes it's also known as the Dyson swarm, Dyson bubble, or Dyson ring, with the structures themselves serving as a kind of a direct way of collecting energy of the star itself, and thus providing a tremendous amount of energy for some sort of an advanced civilization that might require this energy. Now there are quite a lot of other videos covering this in a lot more detail, but the idea itself is kind of sound. And it's so sound, as a matter of fact, that one of the main targets of SETI, Search for Extraterrestrial Intelligence, is actually trying to discover some of these unusual structures somewhere out there around a distant star, with several unusual blinking stars, such as the famous Tybie star, being potential targets. But a lot of these suggestions are more or less biased toward human understanding of technology. We kind of assume that things are going to get bigger, we're going to require more energy, and as a result we're going to have to build bigger and bigger structures, potentially around planets and then around stars. Now in the past I've previously discussed some of the other propositions in regards to this, but for now let's just stick with this. Let's say that this is actually what happens to most advanced civilizations. Well, in that case, naturally, after a typical star, the civilization will probably start looking at some other energy sources. And at the moment, we don't really know of any other source more powerful than a black hole, specifically a supermassive black hole. And so once again, hypothetically speaking, a Type 2 or even Type 3 Kardashev civilization, a civilization that's able to produce really grandiose structures, potentially covering the entire planet or even an entire star, would then most likely seek the center of the galaxy in order to collect the energy from the black hole itself. But the question here is, would such a structure be effective at capturing all of this energy? And if so, what type of energy would it end up capturing the most? And more importantly, what sort of emissions would it actually produce in order for us to detect it from planet Earth? Would it be possible for us to see these structures using modern technology? And so the scientists from a university in Taiwan decided to investigate all of this and produce a pretty interesting paper you can find in the description below. And specifically, they decided to focus on 6 different sources of energy. For example, one of the sources is the cosmic background radiation. And even though here on Earth CMB doesn't really provide that much energy, around a black hole, because of the ridiculously powerful blue shifting effects from the gravitational pull of the black hole, some of the cosmic microwave background ends up being in really high frequencies of light. We've actually discussed this in some of the previous videos somewhere right there. The other potential source of energy is the Hawking radiation, the emissions from the black hole itself. But the most powerful types of radiation is probably going to be coming from the accretion disk itself, because this is literally a bunch of star-like material orbiting around the black hole, and it produces a tremendous amount of radiation. Another type of energy that could potentially be captured is something known as the Bondi accretion, which is essentially a spherical accretion disk that's formed by a traveling massive object through a lot of different interstellar gas. Another extremely powerful event is what's known as the black hole corona. This is so powerful that it's usually visible from extremely far away distances and normally produces tremendous amount of energy as well. And lastly, the sixth source of energy could also be the relativistic jets. These jets are also very powerful and could hypothetically be used to capture the magnetic energy from the black hole itself. And so a lot of these different features around black holes could be used in different ways to capture this energy. But to make this more mathematic, the scientists in this paper decided to focus on three different models. The models of black holes that are similar to the one in the Milky Way, the one that's slightly larger at 5 million masses of the Sun, and the one that's even bigger at 20 million masses of the Sun. Determining in the end that even though it would be pretty impossible to produce an actual sphere-like object, building a sphere of satellites, so basically some sort of a Dyson bubble, would be a pretty effective way to capture and harvest a lot of this black hole energy, with the largest amount of energy coming from the accretion disk itself. Here, the amount of energy that can be gathered from a black hole similar to the one in the middle of our own galaxy is around 100,000 times more than can be captured from our own sun. But if the civilization is also able to capture the astrophysical jets, the energy amount is going to increase up to about 5 times. In other words, the astrophysical jets and the accretion disk represent the largest amount of energy that can be harvested from a typical supermassive black hole. So definitely possible and definitely doable. But could we actually see them and detect them? So back in the 60s, Freeman Dyson proposed that because of the heating up of the object, because of the actual process of the energy exchange, it would be possible to see these structures in the infrared. Essentially, this structure would most likely produce a tremendous amount of infrared light, which would allow the scientists to potentially discover these objects in really far away places in the universe. And upon thorough examination, it should be possible to tell if we're looking at for example, brown dwarf, or if we're looking at a star with an actual Dyson sphere around it. In other words, Dyson himself proposed that it's possible to detect these objects in the infrared. But in this particular case, as you start building larger and larger structures around other objects, such as really massive stars, or in this case black holes, the emitted wavelengths change dramatically as well. As a matter of fact, if such a structure exists somewhere out there, it would be detectable in multiple wavelengths. Actually, even Dyson himself proposed that a hotter Dyson sphere around a much hotter star would most likely emit ultraviolet light, not just infrared light. So what about a Dyson sphere built around the Sagittarius A star, a black hole in the middle of our own galaxy? Well, in this case, the scientists are pretty certain it would emit a lot of ultraviolet light, a lot of near-infrared light, but also quite a lot of optical light, meaning that it would be a multi-wavelength detection and it should be detectable and also visible to modern telescopes. With one specific survey, this one right here known as GALEX, or Galaxy Evolution Explorer, potentially already having enough data collected in order to establish if such a structure actually exists around Sagittarius A star. But the question is, of course, how can you tell if what we're detecting is a natural radiation from the black hole or if it's emissions from some sort of a Dyson sphere? And that right there is probably why we're not going to be able to answer this for a very long time. It would be almost impossible to tell apart the natural radiation from the radiation from some sort of a structure. But in this case, there's at least one proposition from the scientists in this paper. Hypothetically, if there is some sort of a Dyson sphere around the black hole, it's going to also interfere with some of the emissions from the black hole. For example, maybe due to the gravitational effects from the Dyson swarm itself, or from minute changes and minute interactions between the swarm and the black hole emissions. And if one day we actually detect some unusual interactions and some unusual perturbations in the black hole emissions, that could be a sign that there is something there. At the moment, it's just not really possible to do any of this. And really mostly because the black holes themselves are already so chaotic and produce so many different emissions that sometimes are kind of difficult to explain. And so maybe in some future studies, someone is going to come up with some way to potentially detect these structures. At the moment, it's very theoretical, and though it does make sense, it's still extremely hypothetical. Nevertheless, it does imply that maybe somewhere out there, there could be a super advanced civilization using black holes as a source of energy. And according to the scientists in this paper, the amount of energy collected from a supermassive black hole would automatically make this a Type 3 Kardashev civilization, simply based on the amount of energy collected from the black hole. And so overall, a pretty interesting paper and a pretty interesting proposition. But in the paper, they obviously mention a lot of other things. Like, for example, how far away from the black hole would you have to build the Dyson sphere itself in order for it not to fall apart or to burn into a crisp? And for a supermassive black hole in the middle of the Milky Way galaxy, it would have to be relatively far away, approximately 150 astronomical units away from the center, or about 22 billion kilometers. But even at these distances, it would be able to capture quite a lot of energy.